Hello, my 12th standard warriors. Welcome aboard. Good evening, my warriors. How are you? I'm so sorry I was a little bit late, but here I am live. I hope you can see me. I hope you can hear me loud and clear. Hi, Janya. Hi, Ishwar. Hi, Jarima. Hello, Archana. Hello, Rishabh, Kaushik. Welcome aboard. This is Shreyas here, your captain for this channel and the physics master teacher. And today we are going to do one shot for the term 1 syllabus for the upcoming CBSE 12th standard board examination. And if you are preparing for it and you want to revise and you want a one shot series, then yes, you are at the right place. I'll tell you what we are going to do in today's class. First, we are going to start with magnetic field, bar magnets, their properties, the field lines and problems on that. Then we'll go to magnetic dipole moments, we'll calculate it, we'll also find the effects of field on the dipole moment. Then we'll go to magnetic materials, then the Earth's magnetism, then we'll go to Ampere's law, sources of field, then we'll move on to Lorentz force, forces on current carrying wires, all of that, galvanometer, how do you convert a galvanometer into ammeter, voltmeter, EMI, that's Faraday's law, Lenz's law, and then finally alternating current and transformers. So that's the schedule for today, and we are going to revise the concepts. And if you want in detail classes, they are all there in the playlist. But also remember, we are going to practice lots and lots of questions. So if you are ready, put up a heart, put up a red heart in the chat box so that I know your heart is beating really fast. You guys are nervous and you want to solve these problems. Welcome, welcome, welcome Siswa. Hi Rishabh. And some of you probably do not know me. Well, I teach physics. In fact, I've been teaching for almost like a decade now. And here I am just to spread the joy of learning, to instill, the love for physics and to make sure you crack the CBSE examination. Thank you, good and bold girl. Thank you, Dhanush. Thank you, John. Thank you, Aditi, for all the hearts. Thank you, Ishwar. Thank you, Palani. Thank you, Ashika, Gayatri. Thank you so much, Priya. Thank you so much. Renisa, I'm very good. I'm feeling very cold and I'm feeling very excited and I'm as nervous as you are. Trust me. My friends and my relatives are asking me, why are you nervous? You are the teacher. But trust me, whenever exam time comes, I become more nervous. I am, behind the scenes. You do not see me, but I'm always like looking out for new problems. I'm thinking which series to be conducted. I am, solving the questions before so that, you get the right concepts. I'm making sure that the content is ready. All these things are going on in the background. And the only thing running in my mind is my kids should score really well. Because this is very important exam, and plus this is a very scoring exam because this is multiple choice exam. So that's all that is running in my mind. And if you want more such classes, please do not forget to hit the subscribe button, and thank you for smashing the like button down there. Thank you so much. Good evening everyone. Good evening. Acha, my voice is a little bit low. Okay, let me just see if I can change the battery, if that is the concern, if my voice is little bit low. Yes, how to become master in capacitors. Shivam, watch my capacitor pathfinder lecture, you will become master. Okay, so now you're going to see me change the battery. Hold on, I'm just going to change the battery. Maybe some of you were saying the voice is low. Just give me a second. My voice will cut for 15-20 seconds. See now, if it is perfect, give me a thumbs up, put up a yo in the chat box. See if my voice is now much better than before. Yep. So all done with the, yep, perfect. Loud and clear says Rishabh Ishwar. Very good. Yo, super duper se bhi upar. Okay, so meanwhile, I hope you had enough time to hit the like and the subscribe button. So let's start with the revision with me, Shreyas, your physics master teacher. Welcome aboard. Welcome aboard everyone. Yes. So have I done previous year questions? Yes. There are a lot of lectures where I have done it, and I'll be doing special PYQ series for all the 2022 warriors very soon once the term 1 examination is over. Just follow me. You will see all those series. Okay. Let's go ahead. Archana, let me know whatever your doubt is. I'll definitely help you out. Okay. Cool. So magnetic field. magnetic field has certain properties which you need to remember. Most of the properties are similar to electric field except for one. Which is that property? Come on, let's see. How many of you can remember that? See, one of the properties is that wherever the field is strong, the field lines are closely packed. Here it is going to be very strong. Here it is going to be very, very weak. You will see magnetic field lines also never intersect. Also, if you have a north pole, then the magnetic field lines will tend to, appear from the north pole, and they will obviously, tend to go inside the south pole of some other magnet or maybe the same magnet. Very good. I can see closed loops. Perfect. You remember it. See, magnetic field lines will always be in the form of closed loops, but this is magnetic field, and electric field will be always starting from a positive charge and ending towards the negative charge. Although many people might think, sir, magnetic field lines originate at north and terminate at south. Actually, they do not terminate. They continue going in the magnet. They will continuously go and they will finish one loop. Okay, so they will always complete loops. They are never going to start or end at any point. The unit of magnetic field is Tesla. Unit of electric field was Newton per Coulomb. Okay, that's one difference. And most of the things whatever I have told, I have just put it up over here. And let me tell you one more thing, that even a current carrying wire also produces magnetic field, and some of you find it difficult to figure out the directions. So let me just show you how to find out the directions. If it's a straight wire, hold your thumb in the direction of current. The curled fingers point in the direction of the magnetic field. The curled fingers point in the direction of magnetic field. But if it is a coil which is carrying current, then curl your fingers in the direction of current. Look over here. In this case, the thumb is in the direction of current for a straight wire. For a curled wire, for a coil, the curled fingers are in the direction of the current and the thumb gives you the direction of the field. Do you understand the difference? Now you don't have to remember it separately. Whichever thing is round, that is the curled fingers. So in the case of a coil, the coil shape is round, so the current will be in the direction of the curled fingers. In case of a straight wire, obviously thumb is straight, so the current will be in the direction of the thumb. As simple as that. Okay, so that's something which you should remember. Very good. So these are right hand rules, and let me tell you, please don't remember left hand rule in case it was taught to you in school. Please don't remember right ear if you hold it, and then if you hold your left hand using your you're putting it behind and then holding your ear, then this elbow will point in the direction of current, this elbow will point in the direction of force, that head will point in the direction of current. I don't know, you don't have to remember all these kind of rules. Just simple right hand rule always. Okay, so if you have learned any of these kind of rules, please ignore. Okay, moving on. Force between. We have to note it, sir, or hearing is enough. Janya, if you feel like noting it down, then just add it on your NCERT only. Okay, wherever that NCERT book is, over there, or if you have your notes, just keep on adding in case you want to, if you find something extra. But if you feel like practicing it, then just in the rough, practice it, but more attention should be towards listening is what I would say. All right. Now, just like two charges can attract or repel each other, same way two poles of a magnet, let's say this is north pole, let's say this is south pole. The pole of a magnet has the symbol M, small m. North pole has plus m, south pole has minus m. This small m is also called as the pole strength. What is it called? It is called as the pole strength. And opposite poles will attract each other. So if you have a north pole and a south pole, there will be attractive force. North pole and a north pole, repulsive force. This force is very much similar to the Coulomb's law. So instead of K, which is 1 by 4 pi epsilon naught, here you have mu naught by 4 pi, and here you have m1 m2 divided by r square. What is r? R is the distance between them. So what is mu naught? Mu naught is basically 4 pi into 10 to the power minus 7 SI units. Okay, these are SI units. This is also called as the permeability of free space or vacuum. So mu naught stands for permeability of free space or basically vacuum. You should remember these values. Everybody remembers this? Okay, sample papers, Renisa, I already done it, and in fact I did one more sample paper just few days back. Number 2, I'm going to do more sessions after maths examination. I'm pretty sure you want it. Okay, don't worry, I'm going to do it. Okay, mu naught is called as the absolute permeability or permeability of free space. You can see the formulas are very similar. So everything that you revised yesterday in electrostatics is also applicable in magnetism. Keep that in mind. Remember, there was a dielectric constant. Same thing is also there over here. Same thing is also there over here. What is that? Relative permeability, or basically whatever relative permittivity you studied over there is also applicable in this case, but the wording is permeability instead of permittivity. So if you have two poles which are in some medium, if they are in some medium, then instead of mu naught, you will no longer use mu naught, you will use mu. What is mu? Mu is the permeability of that medium. It is the permeability of that medium, and this mu will be relative permeability into the permeability of vacuum. So that's how it works. So relative permeability is the relative permeability is nothing but the ratio of actual permeability upon permeability of free space. You can think of it like that, because if you put mu naught over here, it's just a ratio. If you look at it this way, mu is relative into mu naught. So one and the same thing, it works both ways. So keep this as well in mind. Yep. So yes, Ishwar, I'm going to host many sessions. Rani will talk about it. You can leave a comment. So those of you who are asking some doubt which is apart from the topic, remember one thing, if you have seen my previous videos, I always respond to all the comments that you post after the video ends. So please concentrate on the session, and if you have something to ask which is out of the context, please hold on to it, and after the session is over, leave a comment. Trust me, I'm going to answer it. Okay, so this session is a marathon session today. We are going to do complete magnetism, effects, EMI, AC, all of that today, and it's going to be at least 2 to 3 hours. Okay, so around that. So properties of a magnetic line of force. Okay, so I think I already mentioned this to you. Lines of force are always directed from the North Pole, they end at South Pole, but they continue even inside the magnet. Tangent always gives you the direction of the field, and two lines of force never intersect each other. All this I just mentioned to you, and this is also available for your reference in the PDF, which you can download after the session is over in our Telegram channel. Okay, but this is given to you so that you can quickly revise, brush up. Come on, try and recollect, because there are going to be questions on this. Here is your first question coming up on your screen. What's the difference between permeability and permittivity? Astrophile, permeability is used for magnetism, permittivity is for electric fields. So how much does electric field is permitted in a medium? That's with reference to permittivity. Permeability refers to how much does magnetic field lines penetrate inside a medium. Okay, I hope that is clear. Chalo, Ankit saying option B. You can see 4 magnets over here and 4 compasses around the magnet. So only one of the diagram is correct with reference to the direction of the compass. Which diagram is it? Don't get this wrong. You have to solve this within 1 minute, because in the CBSE board exam you have less than a minute to solve each and every physics question. Okay, because lots of questions you have to solve, 45 questions in 90 minutes. Okay, many of you are inclining towards D, some of you are also inclined towards option B. Well, the correct answer is actually D. I'll tell you why. See, how does the magnetic field line look like? It starts from North Pole, it will go like this, and it will come over here. It will go start from the North Pole, it will go like this, and it will come over here. These arrow marks are very important. Okay, and what does the magnetic compass do? So the magnetic compass, if this is the north, okay, it always orients itself in the direction of the magnetic field. So this magnetic compass will be pointing here, because the field lines are coming like this. Here the magnetic field lines are going back, and finally they are entering inside. So that's why you can see the arrow marks are perfectly matching. Here these two are wrong. Obviously, how can it be this way? Because the field lines are going to go back. So hence option B was wrong. Many of you said option B. Understood? Oh, let's move on. Okay, very easy one. I want this answer within 20 to 30 seconds. This will be a scoring question in the exam. You have to save your time and utilize that time in some more difficult or lengthy question. This diagram shows the field lines of a magnetic field. ABC are the 3 points. Where do you think the magnetic field is strong out of these ABC points? Okay, come on my warriors, please answer this correctly. You cannot get this wrong. 100% score. 100% score. Spam the chat box. Perfecto. Perfecto, my warriors. Proud of you. You're going to save time in this question, and the correct answer is C because the lines are very close by. Perfecto. Let's see whether you can solve this theory question which will come in your CBSE board examination. When a magnet is cut into smaller pieces indefinitely, each smallest piece acts like a small magnet. What can you conclude from this? What can you conclude from this? Think about it, my warriors. Chalo, fatafat. Acha, Ishwar is saying B. Somebody is saying A. Laksh is saying A. Okay. Many of you are confused between A and B. Acha. Okay. What can you acts as a small magnet indicating the. Okay. Okay. Come on. Come on. Come on. Come on. Each smallest piece acts like a magnet. Actually, okay. A, that each piece has north and south poles. Yes, the north and south poles cannot exist independently. That magnetism is an atomic property. Okay, then each smallest piece has its magnetic moment. Okay, okay. Actually, I think this question, something is wrong. One second, let's see what is correct. Yep. So that magnetism is an atomic property. Well, I feel this question should have been which of the following is not correct. Which of the following is not correct? Because obviously each piece will have north and south pole. Definitely, no matter how many small pieces you break it into, there will be north and south pole. Okay, north and south poles cannot exist independently. Yes, monopoles are basically not possible. Always dipoles exist. That is true. Yes. Okay, so I think that word not correct was missing, my bad. Magnetism is an atomic property. No, magnetism is a fundamental property, even smaller than atom. Even an electron which is there, which is spinning, that also has magnetic moment. Okay, even inside subatomic particles also have magnetic moment. So more than atom, it is a more fundamental property of all the particles, elementary particles. Okay, so I'll change it in the PDF, don't worry. Each smallest piece has magnetic moment. Yes, every small piece. So when you take a magnet and you cut it into small pieces, each small piece has north and south pole, and it also has magnetic moment. So all these three things are correct, but you know, magnetism is more fundamental property than that. Yeah. Yes, VSK Chaitanya, we are going to do EMI and AC as well with transformers. Thank you, Siddharth, means a lot. Thank you so much. Thank you so much. Okay, moving on to the next question. This is very tricky. Does a moving charge also produce magnetic field? Yes, definitely, Rishabh. Just like a current carrying wire, it has moving charges. So current carrying wire produces magnetic field, and you know how to calculate that. That's exactly how a moving charge can produce magnetic field. Okay. Alexander, magnetic moment is basically like electric dipole moment, you have magnetic moment. So every small piece will have north pole, south pole, north pole, south pole. What does a dipole make? It makes a magnetic dipole moment. So that's why every small piece has magnetic moment. Is that understood, Jihan Moment? Oh, sorry, who is it? Alexander? Okay. Yes, let's go ahead. Okay, so eddy currents will be more like a theory point. It can come like a passage also. Okay, Mohammed. After term 1, please bring things on KVPR. Definitely. Many of you are saying A and D, confused between both of them. Let's see what the correct answer should be. Many of you are wrong, I think. So you have a bar magnet. You have a bar magnet. And you cut it. So this is the north pole. This is the south pole. And you cut it equally lengthwise and widthwise. So lengthwise is like this, widthwise is like this. Now the moment I cut it like that, what will happen? Let's see. You will get two thin magnets. Okay, you are going to get two thin magnets. This pole will be north by 2. This pole will also be north by 2. This will be south by 2. This will be south by 2. Correct? Okay, so that's what you are going to get. These are the pole strengths. Pole strengths will get divided into equal halves. Now, when you are cutting it like this in the next step, what will happen? Each piece, think what will each piece look like? This will be north by 2, this will be south by 2. This piece will be nothing but north by 2, south by 2. These two bottom pieces will be also exactly like this, north by 2, south by 2, north by 2, south by 2. So what has happened to the pole strength from the original pole strength? It has become half. Do you see that, my warriors? Do you see that? So when you cut it into 4 parts, each pole strength has become half. So that's the concept, and many people make a mistake. The answer is D. It is not same, nor is it 1/8. Yep, D se dhamal bilkul. Ha, definitely, yes Laksh, oops movement happens. So that's why you are coming here to study from me. Next concept. Hi Krishu, welcome aboard. Now, magnetic dipole moment. Some of you are asking, sir, what is that magnetic dipole moment? Yes, we are coming to it. Remember, in current electricity, I told you, if you have a negative charge and you have a positive charge, it creates electric dipole, which is charge into the length. Same way, what is a magnet? Negative pole, positive pole, south pole, north pole, distance L. So when two poles are separated by a distance, it becomes a magnetic dipole. It also has a moment. So instead of charge, you have magnetic pole strength, and length is as it is. So magnetic moment is M into L. As simple as that. Yep. No, K is on fire. It won't be 1/4. Think about it. When you divide a magnet like this, this is north, this is south, you will just get one south pole and north pole. The pole strength does not change. So that's why the answer is 1/2, not 1/4. Okay, coming back over here. Now, just like a bar magnet has its magnetic dipole moment, same way a current carrying wire is also a magnet, because you know current carrying wire also produces magnetic field around it. So a current carrying wire loop is also like technically like a magnet where there is a north pole, this is a south pole. So you can see this is like an electromagnet out here. This is the north pole, south pole, these are the field lines. So even a coil has magnetic moment, and the magnetic moment is NIA. Number of turns, what is N? Number of turns, what is I? Current, what is A? It's the area of this loop. So how much area is there of this loop? Fair enough, everybody got it? Yes. So Shivam, Bacha, what happens is when you have a magnet like this, understand that magnetic pole here and here, okay, this is of this entire thing. So when you cut it like this, half of the north is here, half of the north is here. So that's why the pole strength will get divided into half. But when you have a magnet like this, and when you cut it this way, there is a north, this is a south, this is a north. So the pole strength remains the same, only the magnetic length reduces. I hope that is clear. Understood, my warriors? Understood. Can we move ahead and solve some questions? Okay. Got it, Jania? Very good, very good. So what is magnetic moment? It basically tells you, Jeremiah John, it tells you about how strong the magnet as a whole is. See, if pole strength is more, then there is more south and more northness in the magnet. So the magnet is strong. If the magnet is long, then also the magnet is strong. So a long magnet with larger northness and southness is a stronger magnet. So it's a product of the combined effect of pole strength and the length of the magnet. Okay, and it's a vector quantity. Okay, it's a vector quantity. Got it? Fair enough. Now going ahead to dipole in a field. Just like electric dipoles, when you place it in electric field, what does it experience? Torque. And what does the torque create? Potential energy. If you were there in my yesterday's session, you already know it. And quick revision, in electricity, you had the torque is dipole moment cross electric field, and potential energy was minus dipole moment dot electric field. Cross dot. Here, instead of Dipole moment, you have magnetic moment, and instead of electric field, you have magnetic field. Same formula you can see even for potential energy. Now, what does this mean? For example, somebody takes a compass. Okay, what is a compass? It is a needle, and obviously it has some north pole and it has some south pole. Fair enough. So if there is a north pole and south pole, what does it mean? It also has magnetic moment. It represents the strength of the magnet. Now you place it in Earth's magnetic field. This is the Earth's magnetic field, external magnetic field. What will the needle do? Come on, my warriors, it's going to deflect. Yes, Netra, this will be also useful for JEE Mains, definitely. So it will deflect. And what will the magnetic moment try to do? It will try to align itself in the direction of field. So hence there will be a torque on it. And this torque will be given by M cross B, which is MB sine theta. What is theta? Theta is the angle between M and B. Fair enough. And think this way. If you try to rotate the needle, leave it, it goes back. As if it has stored energy. You deflect the needle, leave it, it goes back. So there is some stored energy in the magnet when you deflect it from the equilibrium position. So that's why it has potential energy. Remember that formula. It is minus MB cos theta or minus M vector dot B vector. Understood? So I hope you felt that energy right now. It's like spring action. You rotate it, it comes back. Okay? So minus M dot B. Let's start solving the questions. Why is it negative? Keys on fire, it comes out to be negative when you derive it. Okay, so it's there. Derivation has been already done in my regular classes, plus it's there in NCERT. So when you do it by proper definitions, work is integral of force dot ds, you do it, you'll get it. Yes, it will be in stable equilibrium when they are aligned. Okay, yes. Let's see how many of you can do this. Yeah. So what happens when current is passed through a spring? It will be very interesting. A lot of interesting things happen, and I have discussed that in my numerical course if you are a part of it. By the way, that's one of my questions. A magnetic dipole moment is a vector quantity directed from south to north, north to south, east to west, west to east. Okay, very simple, south to north. What is east and west? Where did east and west come from? Obviously, it's a vector quantity. Just like electric dipole goes from minus to plus, same way for magnet it goes from south to north. Okay, not north to south. A lot of people make a mistake over there thinking north to south. No, it's from south to north. Moving on to the next question. Yes, Islamic media, yes, definitely. It can probably produce, magnetic fields around it. So moving electric charges can create magnetism around it, definitely. A bar magnet of magnetic moment this much is placed in magnetic field. How much work is done in turning the magnet from parallel to anti-parallel position relative to the fielder direction? Okay, come on my warriors, think not more than 1 minute, okay? Let's see if we can do this within 1 minute. So try to visualize the question first. A bar magnet of magnetic moment this much is placed in a field of this much. Earlier it was parallel. So let's say this is where the magnetic field was and this is where the magnetic moment was. And then what you do is basically the field remains as it is, but you have turned the magnet anti-parallel. Okay, so you have turned it and made it ulta. So the question is, how much work needs to be done? Well, if this is initial position, this is final position, the work done is change in the potential energy, which is final minus initial. So let's start solving this. Whatever work you do goes in changing the mechanical energy of the system. Many of you are confused between A and D. Very few of you are also saying B option. Let's figure this out. Okay, meanwhile you can keep trying. Final energy. Remember, finally the angle between them is 180. So minus MB cos 180 minus initial energy. The angle between them is 0 degrees. So minus MB cos 0. Makes sense? Remember the formula is negative MB cos theta. So next, cos 180 is minus 1. Minus into minus is plus. So plus MB. Minus and this, okay, let's get rid of it later on. This cos 0 is 1. So this will be minus MB as it is. So minus minus plus, so it will become 2 times of mb. Now I think m value is given. What is the value of m? It is 2.5. What is the value of b? The magnetic field is 0.2. 2 into 2.5, 5. 5 into 0.2, that's 1. Hence the correct answer is option A. How many of you got it? I can see Ashika, Ishwar, Darshini. Very good, Durga, very good, Sriji, excellent. How you missed the initial part, but it's okay. Join in now, whichever part you have missed. So for all the latecomers, no matter when you join, watch the missed part later on. Wherever you are, continue from there, because live class experience is completely different, right? And I'm pretty sure you agree with that. Okay, option A is correct. Let's move on to the next one. Okay. So Terry, you should put that comment in Wazim sir's class for sure, okay? Because I'm not sure of what are the timings of chemistry classes. Okay, so a circular coil of n turns and radius r carries some current I. It is unwound and again rewound, but this time when you make a coil of radius half of the original radius. Same current is passed. What is the ratio of the magnetic moment before to now? Let's see how many of you can get this. Devansh saying A, very quick. All right, come on my warriors. Let's see how many of you can do this. Let me draw the situation for you. You have a coil. How many turns are there? It has n turns. Okay, it carries current I. Obviously, there will be some magnetic moment. Now you unwind it. That means you make it a straight wire. And now you make it as a coil or smaller radius. Okay, now one thing is clear. When you unwind it, so this is unwinded, and here the radius was r, the perimeter of that wire, basically the length of that wire, will be 2 pi r. There were n turns, so into n, correct? The perimeter of that wire, the total length of that wire will be 2 pi r, which is circumference, into n turns. When you make it into a smaller circle of radius r by 2, I think the number of turns will increase because you have made the coil smaller in radius, so turns will change. Do not forget that. So this time when you make this r by 2, to keep the total length constant, the n should become 2n. Everybody understanding it? To keep the product constant, if radius becomes half, n should become 2n. So here this will have 2n number of turns. Everybody understanding it? Great. So this will have some new magnetic moment m1. Understood? Clear? So what is the value of m going to be and m1 going to be? Let's think. In general, m will be n I a. Area will be pi r square. Now this is magnetic moment initially. When you change it, what have you changed? N has become 2n, r has become r by 2. So I has not changed, pi has not changed. Here n has become 2 times, r has become r by 2. So r by 2 square will make it 1/4 times. Do you understand it? When I divide r by 2, the square of it will become 1/4 times, and this has become 2 times. 2 times into 1/4 times is how much? How much is the combination? It's going to be half times. So if RHS changes half times, LHS also should become half of the previous value. Is that understood, my warriors? Is that understood, my warriors? Yep. So the ratio of the magnetic moments of the new coil to the original coil. So the new coil will be half. That means the answer will be A. It's A, not B. It's not B. Be careful. New coil to the old coil. New is less, old was more. So that's why it's 1:2, not 2:1. Don't make that silly mistake. No, Alexander, think about it again. Be careful. Look at the ratio. What have they asked? New to old. New coil has become half times. Got it? Okay? So don't make these mistakes. See, understand, learn from these mock tests, learn from these sample questions. That is a big takeaway in the exam. These are the mistakes you are going to make and you will feel very guilty and very bad about it. So avoid it. Always see what has been asked. Don't just find it out blindly. Oh yes, and we are correct by the way. Yep. Okay, chalo. Let's move on to the next question. We have a magnetic needle suspended parallel to a magnetic field. It requires √3 joules of work to turn it by 60. How much torque you need to maintain it in this position? Let's see how many of you can do this. Okay, chalo. Let's start doing it. I'll give you 1 minute to solve it. Okay, I might take more time because I'm going to sit and explain this problem to you. So we have magnetic field over here and we have a bar magnetic needle parallel to the magnetic field. So that means the magnetic moment is like this. Slowly what you do, you turn that magnet around and you turn it by 60 degrees. Okay, so you turn it by 60 degrees. So this is your final position. Obviously there will be a torque to pull it back. You have to apply a torque in the opposite direction to prevent it from going back. The question is how much torque you need to apply. So for that, I think I just know that the magnetic needle suspends, I know only the work, I don't know the field, I don't even know M. That's the funny part. See, to find out the torque, because obviously it will be experiencing a torque due to the field, and the torque that you are going to apply externally will be opposite. So the torque needed will be MB sine 60, which is MB √3 by 2. I don't know M, I don't know B. So make use of the first information. Work done is given. Work, I just told you, it is final minus initial potential energy. Final energy is minus MB cos 0. Minus, sorry, my bad. Final energy is not this. Final energy is this. So it is minus MB cos 60. Minus initial energy, that is MB cos 0. So let's see what do we get. So it will become minus MB cos 60 is half. So minus MB by 2 minus, and there should be another minus over here because it's minus MB cos theta. So cos 0 is 1, minus minus becomes plus. So plus MB. So this will become MB by 2. Okay, and the work done is given to be √3. So therefore MB is equal to 2 √3. Acha. So let's substitute the value of MB which I got over here over there. So this will become 2 √3 into √3 by 2. 2 goes, √3 into 3 will become 3 joules or whatever, 3 Newton meter because it's torque. So 3 Newton meter, but joules and Newton meter almost the same unit, but yes, it should technically have been Newton meter. That's the answer. Perfecto. I can see keys on fire. Kaushik, Vingesh, Sriji, Mani, excellente. Okay. So in case my timetables of the classes are posted at 2 places. One, YouTube community. Second, it's also posted in our Telegram channel. So both the places you will see my daily timetable and daily schedule, but most of my classes usually are at 7:30. Because today's class is longer, I started it at 6:30. Okay, moving on to the next one. Okay, so any tips for English term 1? I don't know, probably just start studies tomorrow. 1st December is a good day to start English studies. Tomorrow onwards, don't study for maybe too much for physics, chemistry, maths. Okay, just go through your English books, just revise the grammar, solve English questions. That's all. Just get into the mood and keep reading newspapers and some creative things in case you want to, just get into that, set that mood right. That's all. Okay, that's all you need to do. Okay, so if you take a charged particle and you revolve it or you rotate it, then the charges, when they rotate in circular paths, okay, when the charges, so let's say you take a charge and you go in circular paths, these are like current loops. And what do current loops create? Current loops will obviously create magnetic field around it. So they create magnetic field around it. And the moment they create magnetic field, obviously they will have magnetic moment. So when you take a charged object and spin it, it produces magnetic moment, and the formula for that is simple. Magnetic moment by angular momentum is the charge of the body by 2 times the mass. What is this? This is angular momentum. Very, very important. This is very easy to remember. This is the mass of that body. This is charge, this is magnetic moment. This is something which you should know. The second thing that you should remember is the current which is created. The current, which is I, is charged by time, the time period of revolution, and the time period is 2 pi by omega, so it is q omega by 2 pi. So that is the current which is created in that loop. Okay, is that fair enough? Everybody clear about this? Cool. So Vignesh, there is no easy answer for that. Okay, because if you take magnetic monopole, then it behaves like non-conservative, but if you take a dipole, then it behaves like conservative. But magnetic monopoles do not exist, so for all the practical reasons, it becomes conservative then. Okay, so these are the two important formulas. Let's move ahead. Devansh, I would suggest please watch my Pathfinder lecture. It will help you. It will take you 4 or 5 hours, but you will become very strong at it. But if you are strong at other topics, then focus on other topics. Leave current electricity for now. You can focus on it after the term 1 exam. Okay, so if you have 1 week topic, you can leave it. All right, moving on to the next one. Okay, so Shivam, all you need to do is you need to have enough practice. That's the only simple solution for that. Let's see how many of you can do this question. First of all, we have an electron which is going around a proton producing a magnetic field of 16 Weber per meter square in a circular coil of radius 1 angstrom. What is the angular velocity going to be? Let's draw the diagram. So we have that electron, okay, which is going in a circular orbit with angular velocity omega. So this is your electron. Obviously, it is going to create a magnetic field. Yes, magnetic field is given. Magnetic field is 16 SI units. So the question is, what is the omega? Interesting. The electron going around this is like a current coil. It's like a current coil. And what is the magnetic field due to a coil which carries some current? Do you remember that formula? It was mu naught I by 2 times of radius. Do you remember that mu naught I by 2r? That's the formula. But I don't know the current. Now, just few minutes back I told you what is the current due to a charge which revolves with some angular velocity. Current is that charge divided by 2 pi, and this omega goes on the top. Do you remember that? This was the value of the current. That's it. Now just put off everything over here. Put off everything over here and you'll get the answer. But before that, let's do a small modification. Mu naught by 2 into 2 is 4. So I'll take mu naught by 4 pi separate. Q is electron charge. Omega I don't know. And R will just come over here. So just start substituting. B is nothing but 16. Mu naught by 4 pi is 10 to the power minus 7. E is 1.6 into 10 to the power minus 19. Radius is 1 angstrom, which is 10 to the power minus 10 into omega. Let's see what and all gets cancelled. 1.6 and 16, this will become 10. Okay, fair enough. So this 10 to the power minus 10 and 10 to the power minus 19, this will become 10 to the power minus 9. Fair enough. 10 to the power minus 9, 10 to the power minus 7, that will become 10 to the power minus 16. When it goes here, it will become 10 to the power plus 16. So 10 to the power 17. So omega should become 10 to the power 17, which is option A. Check this out if this is clear. Yep. How many of you got it? How many of you got it? It looks like Mani said A. Some of you said C or D. So you had to use 2 formulas. First formula was over here. Okay, this was the first formula. The second formula was right over here. Current is Q omega by 2 pi. That's it. Yep, option A. Correct. It is correct, Laksh. Definitely. So, Vadhu, you should just be used to solving MCQs. There is nothing special about it. I mean, even if the options were not there, you should still get the same answer. It's just that the options are there just for convenience sake, because it's difficult to check the theoretical answers if you write it. Number 1. Number 2, sometimes options help you to eliminate, and if you just look at the options and then try to solve the question, it will confuse you more than actually helping you solve the question. So preferably, don't solve the questions at home by looking at the options. When you're solving the exam, yes, you can take help, but not entirely. Okay, let's move on to the next questions, but before that, okay, so expert gamer, I don't know where you felt the problem was there. See, first of all, remember, if you have a coil which carries current, anyways, I'm going to discuss that formula. There is a field which is created. That field is given by mu naught I by 2r. That's one thing. The second thing is, whenever you have a charged particle and it goes around a coil, it goes around a circular path, then it is like a current carrying loop only. That current is Q, okay, by 2 pi into omega. So these are the two concepts that I have used. Is it making sense? Yep. Is that clear? Is that clear? If you are weak at magnetism and matters, should I revise and cover it? Yes, because it's a big chapter and you cannot afford to leave that big concept of magnetism, magnetic field, Ampere's law, forces. It's very big. I would suggest you should do it, definitely. Okay, let's see this. Vignesh, why don't you post your comment later on? I'll definitely respond to it. I'm giving you a table of dia, para and ferro, and what you should do is you should remember all the properties. Okay, I'm attaching this PDF in the I'm attaching this in the PDF, and the PDF is there in the Telegram channel. Okay, so you have to download it. Just to give you a very rough idea between dia, para and ferro, both dia and para are actually not magnetic, but they become magnetic when external field comes. Okay, so if you take a magnetic material, maybe let's say this is a magnetic material, or let's say this remote is a some material. When you see it normally, it does not have magnetic property, but when you apply external field, it shows magnetic property. Ferromagnetic is always magnetic. I mean, it's permanent magnets. So then your obvious question will be, sir, what's the difference between dia and para if both are non-magnetic? Simple answer. When you take dia or para and you apply external field, then a diamagnetic produces magnetic field in the opposite direction. It opposes the external field, it repels the external field. But if you have a paramagnetic material, then it produces magnetic field in the same direction. So that's one thing, and that's something which you can remember. Okay, so let's see whether you can do this. I saw it in the portion, so I'm not sure whether it was deleted. When I downloaded the portion, it was there. Okay, so I'll just do this, maybe 1 or 2 questions, and then we'll quickly move on to the next question. Shanu, how about this? Just leave a comment after the video and I'll definitely help you out. For a diamagnetic material, which of the following statement is correct? Relative permeability will be more than 2, less than 1, more than 1, equal to 1. What if it comes in case study? For example, this concept can come in case study or a passage question. So never know. So let's just do this. Yes, the answer is relative permeability is less than 1. Oh, it's a diamagnetic. Be careful. For para, it is more than 1. For ferro, it's much higher than 1. So relative permeability for dia is like 0.7, 0.8, 0.4. For para, it is like 1.2, 1.52. For ferro, it will be like 10, 70, 50, like that. Okay, so it's option B. Okay, one more question on this. When you increase the temperature and you keep increasing it, you will see some material will convert into some another material. It will change its property completely. Okay, come on, think about it. Smriti, it's okay, bacha. Even if you are late, just join in. Whatever part you miss now, watch it later on. Don't worry. Watch the live class because that's more fun and interesting. Okay, let's see how many of you can get this. Yep, their temperature is called as Curie temperature. So after Curie temperature, a ferromagnetic material behaves like a paramagnetic material. Okay, so let's go to Earth's magnetism. Earth's magnetism, everyone, quickly. Yep. Chalo, let's see the formulas related to Earth's magnetism. Okay. Earth's magnetism, don't tell me that is also deleted now. Okay, it's there because I was seeing. Yep, Sharmisha, even if you're joined right now, it's okay. It's okay. All right, let me just have some water. Okay. Yes, there are good chances that the same questions or the type of the questions will get repeated in the board exam. Yep. Okay. Now, first thing you should understand that the earth has magnetic properties, and the earth can be assumed like a magnet, like a big bar magnet, okay? And the magnet is exactly opposite of where you imagine the north and the south is. So for example, okay, I think this diagram is slightly wrong, but anyways, this should be south, and oops, this should be north. Okay, fine. At the North Pole, you have the magnetic South Pole, and at the South Pole, down near Australia, near Antarctica, you have the magnetic North Pole. And the field lines emerge like this, they go around and come back over here. That's how the field lines look like, because magnetic field lines always start from the north, they go like that and come over here. So now imagine a person near the pole. Imagine a person near the pole. How will he see the magnetic field lines? The magnetic field lines will be almost, just imagine there is a Pandu standing over here. Just imagine this Pandu is standing over here. For him, the Pandu, the magnetic field lines will be vertically down. The magnetic field lines will be vertically down. Everybody agreed? Ash or OP or O0P. I'm going to explain that. Observe, listen to me carefully. Okay. Now, similarly, if you are near the equator, okay, so let's say you are near the equator. This is our equator. And let's say a Pandu is standing. So Pandu will be standing like this. He is not going to fall. Okay, gravity is not down. Gravity is there. Don't get confused. How will the magnetic field lines look like? The magnetic field lines will touch his hair and they will cut his hair. The hair will fly off, right? Okay, so the magnetic field lines are going to go like this. So for him, the magnetic field lines are horizontal. The magnetic field lines are horizontal. Here the magnetic field lines are vertical. Okay. Now the angle which the magnetic field lines make with the horizontal, the angle which the magnetic field at that place it makes with the horizontal is called as the dip angle. Here the magnetic field with the horizontal makes 90 degree. So the dip angle, how much is the dip angle? 90 degrees. Here with the horizontal it is parallel. So the dip angle is 0 degree. Let's say the Pandu was somewhere over here. The Pandu was somewhere over here. Then for that Pandu, the magnetic field line will be like this. There will be, oops, let me just draw another diagram probably. Okay, sorry, this was north, I believe. Yep. So imagine for this Pandu, okay, the field line will be like this. So that field will have two components, the horizontal component, the vertical component. The angle which it makes with the horizontal is called as the dip angle. So this is basically the dip angle. Everybody clear about this, my warriors? Perfecto. Yep. Okay, great. Now the next thing that you should know, what is the relationship between BV, BH, B? Yep. So you can clearly see that this is a nice triangle which can be formed. You shift BV over there. You shift BV. Sriji, can you just go little bit behind? Can you go just little bit behind and replay the same part? Even in a live session you can do that. Just do that. Okay. So you will see that tan of theta will be opposite side of, what is opposite side? BV divided by adjacent side, which is BH. So quick revision. Earth produces magnetic field. North pole is down south. South pole is the up north. The field lines go like this. At any of the poles, the field lines fall straight into the ground or come out of the ground. So the angle which the field makes with the horizontal is 90. That's the dip angle. At the equator, they just shave off your head. So they are parallel to the ground. So dip angle is 0. But at any other place, it will make some angle. It will have two components, horizontal and vertical. So tan theta is BV by BH. Very, very easy. Fair enough. Perfecto. Yes, Rishabh. bv square plus bh square is b square. That's simple vectors. Definitely. Definitely. Now, there is one more thing over here. One more thing. When you take a magnetic needle, okay, let's say you take a magnetic compass and it points this way. This is north, this is south. If you actually keep going, taking the magnetic needle, if you keep going, when you reach near the pole, you will find you have landed at a completely different place. It's not the actual axis of the earth. The reason is the actual south pole and the geographical pole are not at the same place. They are slightly different. So the earth's magnetic axis itself is tilted. So what am I saying? The earth's magnetic axis is tilted with respect to the earth's axis itself. So that's why when you start going towards the north using magnetic properties, you will reach the magnetic pole, but you will not reach the geographic pole. The geographic pole is where the actual poles where you usually think are. That's where the axis of the earth is. The earth spins around these two poles. Is that clear? Now, the idea over here is, see, think about it. Okay, imagine, okay, just imagine a cube, imagine a room, something like this, okay, let's say, and, okay, this is my room, okay, something like this maybe, and imagine the plane, okay, just imagine the plane which will actually lead you, the plane will actually lead you to the, geographical pole. So if you keep walking around it and you draw a vertical, and if you slide that vertical line, just imagine that will be this wall, and that plane which will eventually lead you to the geographical pole is called as geographical meridian. What is it called? It is called geographical meridian. The plane which will contain the Earth's actual spin axis. Okay, that plane which will contain the Earth's spin axis. That is what is called as geographical meridian. But remember, Earth's axis and magnetic axis are different. So if you actually walk towards the geographical axis, you will reach the geographical pole. But you will have to go in slightly different direction to reach the magnetic pole. So maybe you have to travel somewhere else. Maybe you need to travel in some other direction to reach the magnetic pole. So that plane is called as the magnetic meridian. What is it called? Magnetic meridian. So if you travel along magnetic meridian, you reach the magnetic pole. If you travel along geographic meridian, you reach the geographic pole. And the angle between them is called as declination angle. What is it called? Declination angle. Is that clear, my warriors, now? Is that clear, my warriors, now? Fair enough. Yes, Tailu, I will be covering wave optics after the board examinations. Thank you, Rinisa. Thank you, Disha, so much. Looks like it is clear now. Yep. Now, can you locate the dip in this diagram? Yes. Where will the actual magnetic field be? Actual magnetic field will be in always the plane which has magnetic properties. Magnetic field will always be there in the magnetic meridian. So this is basically the dip. So if you remember, imagine a room, one wall is geographic, the sliding or the inclined, the diagonal wall, okay, from one edge to the other edge is the magnetic meridian. From one corner to the other corner, that line will make dip angle. That's what it is. Done, done. Got it, my warriors? Perfecto, my warriors. Hit the like button, hit the subscribe button. Yep, so it's all there over here. It will be there. Okay, don't worry. You can write nice theory after listening to this class. Trust me, if you read, even NCERT after this, it will help you. And also, if you need even more help, most likely you would not, but still, just in case, you know what to do. Go to playlist, go down, Do you see? Where is it? Yep, where is it? Oops, where did it go? Okay, there we are. Physics, J physics. Okay, okay, looks like the playlists have changed today. Is it? Okay, looks like the playlists have changed. For some reason, I'm not able to see J. Oh yeah, J maths physics. Okay, looks like somebody has changed the playlist. My bad. Sorry, guys. Okay, I was expecting physics, chemistry, maths, but okay. So over here, you will be able to find it. Okay, over here you can see magnetism, Ampere's law, forces, force on current, advanced questions. Do you see magnets and Earth's magnetism? There is a separate class over here. You can play this class, okay, if you want to. You can watch this lecture after skipping this ad out here. Yep. I don't want to buy any kind of oil or diesel, so sorry. Okay, thank you. And that's where I have taught bar magnetism and Earth's magnetism in detail. A lot of questions out here. If you want it, all classes are there for free, okay? It's just a matter of your effort and time. Okay, moving on to the questions now. Okay, here we have it. Yes, both the lines lie in two intersecting planes. Yes, 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 yes. Dip angle is also called as the inclination angle. Yes, definitely. Yes. Okay, moving on. Hello Niharika, good evening. Okay. Oh yes, Rishabh, I am looking more young in that video. Yes, I think that video was some 4 months or 3 months old, and looks like I have grown very old in these last 3-4 months. Maybe I need to do some more exercise. Okay, somebody is saying 60 degrees, somebody is saying 45 degrees. Okay, so what is it? Is it B, 45? Yes, it is. And the answer or the reason for that is very simple. The Earth's components, magnetic field's components, horizontal and vertical, are equal. So if that is equal, obviously the net magnetic field will make equal angles. This will be 45, this will be 45. So this is the dip angle. Done, done, done. Moving on. Okay, let's see whether you can solve the next question. Very good. All of you got full marks in this question. Perfect. Very good. In the magnetic meridian of a certain place, okay, the horizontal component is given, and the question is the angle of dip. If it is 60 degrees, what is the total magnetic field at this location? Hint, draw a triangle, mark the values, you will get the final answer. Very simple it is. Just draw the triangle. That's it. If you just draw the vector triangle, you will get the answer. Let's see, some of you have already started answering. Okay, so we have vertical, horizontal, everything. So horizontal, and this is vertical, this is the total. The angle of dip is 60 degrees. This is 90 degrees. Horizontal is 0.26. Clearly from this diagram, you can see this is the hypotenuse, this is the adjacent side. So B cos 60 is basically BH. So B cos 60 is half, is BH. BH is 0.26. So B will be 2 into 0.26, which is 0.52. Gauss. Gauss is also a unit of magnetic field. Wow. Hi Shubham, Samal, welcome aboard. Very good, very good. C for Capto, finally. C for Capto. Hi Aishwarya, long time. Looks like you're a little bit late. But yes, I know you also have sessions on Vedantu Pro. But good, you could find some time. Hi Tomlin, welcome aboard. Join in Bachcha Log, join in. All those of you are joining in late, watch it from wherever you're watching now. No need to replay. You can do the replay part later on. It's not going to go anywhere. Okay? And do not forget to hit the subscribe button so that you do not miss any of the classes. Okay. Oh, you two are a pro student of Sankalp NEET, Neville. I didn't know that. Oh, is it Neville? You're in class 11th. Okay. Looks like you're going to get some confidence, or probably you're going to give some inferiority complex to all the 12th standard students out here. Okay, chala, let's do this. The total intensity of Earth's field at equator is 5. What is the value of the field at the pole? Very interesting question. Many of you are going to make some mistake. Let's see who can answer this correctly. For sure, many of you are going to make some mistake. Okay, Ishwar saying C, Thalu also saying C. Very interesting. Pranav saying B. Acha, interesting. Let's see. Okay, many people saying C. Some of you are saying basically, yeah, that's 0. Somebody again changed the answer to D now. Okay, somebody saying B again. All right, so when you draw the Earth's field, you can think of Earth like a magnet, which is, this is the North Pole, this is the South Pole or something like that, and the Earth's fields are going to look like this, correct? Now this is where the pole is, and obviously this is where the equator is. This magnet is nothing but like a magnetic dipole moment, and this is the axial position and this is the equatorial position, and we all know the formula for magnetic field at axial position and equatorial position. At equatorial position, remember in electricity we have studied it, still it is applicable in magnetism. It will be mu naught by 4 pi. At equator it will be m by r cube. Yes, that's the formula. And at axial position it will be mu naught by 4 pi 2m by r cube. Same thing like electrostatics. Is it now clear? Now are you recollecting those old formulas from electrostatics? That means on the pole the field is twice as strong as the equator. So pole is twice as strong as the equator, and at the equator if it is 5, so at the pole it will be 5 into 2, which is 10. That means, where is it? Option D. Yes, Durga Kumar, your name. Yes, Fiji. Yes, Greyluk. D. Perfecto. Will they provide rough sheet? I think so, they should. I mean, yeah, they should, right? Or at least they should provide rough space, okay? Or if they don't provide rough sheet, then just a simple thing, just call the invigilator and then please ask the invigilator, sir, come here 1 second, please turn back, and then just write on him. That's it, okay? Just write on the invigilator's back. You can do rough work over there, and then you can send the invigilator to your friend. You can send it, sir, my job is done. The next friend calls him, and then he can see the answer which you wrote on the invigilator's back. Okay, so that's how you can help your friends. Cool. Chalo, let's go on to the next one. What do we have? Yeah, we have Biot-Savart's law. Chalo, let's see what is Biot-Savart's law. Amina is happy, finally. Okay, good you came here. The difficulty level will be very easy. Chill. Hello Anushka, welcome. Okay. Yes, that's a great way. Very true. Look at that smiling faces. Please come out like this and go also like this. Don't let that smile go away. Okay. Chalo. So a current carrying wire produces magnetic field around it. So if the current in the wire is I, the element whose field you are trying to find is dl, you are standing at a distance r, then the field at this point due to this small element dB will be given by mu naught by 4 pi, that's a constant, I dl sine theta by r square, okay, or you can also write it as mu naught I by 4 pi, okay, I goes there, dl cross r hat is the unit vector, and that's why when you cross it, it will become I dl, that sine theta will also come over there. So what is theta? Theta is the angle between the position vector and the length vector. That's what the formula is. Keep this in mind. All right. Now, the next important formula which you should remember, let's see. Fields due to different geometries. Fields due to different geometries. Okay. So, first formula. Field due to a coil. I think I just gave you the formula for field due to a coil at the center. At the center, the formula is mu naught I by 2r, where r is the radius. But if you are not at the center of the coil, you are somewhere here, that distance is x, then the formula is mu naught I r square divided by 2 into r square plus x square raised to 3 by 2. If you ever get confused in this formula, let me tell you, if by chance you substitute x equals to 0, that means you are at the center of the coil. So x equals to 0 means you are at the center of the coil. You should get back the original formula. Let's try this. You will get mu naught I r square divided by 2. r square plus 0 whole raised to 3 by 2. This will become mu naught I r square to r square raised to 3 by 2 is just r cube. R square by r cube is nothing but 1 by r. So exactly what we needed. So this is a special case of this major formula. Fair enough? Got it? Perfecto. Moving on to the next important formula. Magnetic field due to a straight wire. Now there are again one general formula and one special formula. General formula is when the wire is not infinite. It makes angle theta theta, and then you are at some distance r from that current carrying wire. Then the formula is mu naught by 4 pi, current by that distance is the distance from the wire, into sine theta 1 plus sine theta 2. What is theta 1 and theta 2? Is the angles which the ends of the wire subtend. Yep, angles with the ends of the wire subtend from the point where you want to find the field. Okay. But if it is an infinitely long wire, then theta 1, theta 2 both will become 90 degree. Sine 90, sine 90, 1. 1 plus 1, 2. 2 divided by 4, 1 by 2. So hence that formula will become mu naught I by 2 pi distance. Okay, so that's how it becomes. Perfecto. See you. All the best, Aishwarya. Take care. All right. Perfecto. This is another geometry. So coil done, wire also done. Let's solve some questions. What is A? A is the distance. So in this formula, let me just put it over here, just for your reference. This is basically A or R. So actually both the formula should have had the same symbol. I think a printing mistake. So either you make this as R and write over here as R, so that will be easy. Okay, fair enough, done, but that is understood, I guess. Let's solve the question. All right, here we have a coil which is 2 meters in radius, carries 8 amperes of current. Now the question is, what is the magnetic flux density at the center of the circular conductor? What is the meaning of flux density? Flux per unit area is nothing but field. So it's just a different way of calling magnetic field. Some books also use the word magnetic induction. Don't get confused. It's just like your pet names. You have some name over here, but your actual name is different. At home you are called something else. In school you are called something else. So it's basically different names given to magnetic field. Just that's all that you should keep in mind. Yeah. So let's try to find this out. So magnetic field for a circular conductor, that means mu naught I by 2r. Okay, let's start substituting the values. Mu naught is nothing but 4 pi into 10 to the power minus 7. The current is 8 divided by 2 times of radius. The radius is 2. Fair enough. So what will we get? 2, 2, 4 cancels. So I think we just have 8 pi into 10 to the power minus 7. So do we have it? Yes, we have it over here. Do you see that, my warriors? That's it. That's the answer. Thank you, unforgettable love. Thank you, beta. Thank you for all the love. All right. So let's go ahead. Option B was correct. Very good. Come on. Quickly try to solve this question. Many of you are going to make a small mistake, but I hope you don't. This should be solved within 20 to 30 seconds. The strength of the magnetic field at a point R near a long straight current carrying wire is B. What is the field at a distance of half the previous distance? B by 2, B by 4, 2B, 4B. Hello Geetika, welcome. Good evening, bacha log. Okay, somebody saying C. Let's figure this out. Sure. Looks like we have a lot of spam out here. Very good, I love this. Very good. Oh, who is that? Devansh is saying D. No, Devansh, it is not D, it is C. And the reason for that is when you have a wire and you are at a distance R, then the field at this point due to this current carrying wire is mu naught I by 2R. So if this becomes half, obviously this B will become twice, because denominator, which is below, is becoming small, the ratio will become big. So it becomes half, numerator becomes twice. Correcto? That's it. Perfecto. Amazingo. Let's move on to the next question. This is also very tricky. Let's see how many of you warriors are going to crack this question when it comes in the CBSE board examination term 1. Let's see. A straight wire of length 2 meters is taken and a current of 1 ampere is passed through them. The field at a point along the axis of the wire at a distance of 3 meters from either this side or that side is given by how much? Okay, let's see how many of you can do this. Okay, so we have a wire. It's a length of 2 meters. It's also carrying some current of 1 ampere. The magnetic field at a point along the axis. Let's say over here, what is the field? That's the question. It's very easy, very good. Very good Anjali, very good VSK, Ishwar, Riya. Very good Sashanka, very good Mani, Ashika, Pranav, very good. The answer is a big fat 0. On the axis there is no field. Only when you are here will you get a field of mu naught I by 2r. Okay, that's a different story. Answer is 0. Perfect, perfect, perfect. Okay, a lot of students are going to waste a lot of time. Now this is a tricky one. This will take some time for you to think, but 1.5 minutes, not more than that. A long wire carries current. It's bent into a loop of 1 turn. The field at the center is B. You take the same wire, but now you bend it into n turns. Now the field at the center of the wire, center of the loop will be how much? So let's see, what do we need to do? First, we have a long wire. Okay, so that long wire is like this, of length L. You bend it into a loop of certain radius r. The current is I. Then the field at the center, okay, so the field at the center is basically B. Now you again open it, but now you have n turns. So that means the coil will have more turns, the radius will be small. So here you have n turns. Here you had 1 turn. So now the new field is how much? So the new field is how much? That's the question. B, D. Students are confused. Let's find this out. See, the total length of the wire is not going to change. In the first case, the length will be 2 pi r. Okay, so 2 pi r. And the magnetic field will be given by mu naught I by 2 pi r. Okay, and this r is basically L by 2 pi. So L by 2 pi. So this 2 pi and this 2 pi gets cancelled. So you will get it as mu naught I by L. So that's the old B. In the case of the new B, understand there is a small difference. The new B will be mu naught I, but there will be n turns. So into n divided by 2 pi. The new radius will be different. Yes, the new radius will be different. Think of it this way. The same length will be 2 pi, the new radius into n times. 2 pi r, 2 pi r, 2 pi r, 2 pi r, n times. So the value of small r over there technically will be L 2 pi below, n below. So 2 pi and n. 2 pi goes. So you will have mu naught I by L. N and n does not cancel, it multiplies, so it will become n square. Do you see what is this value? Mu naught I by L, it is the old B. So it will be B n square. So where is B n square? That's option B. Yep, all those of you said that D is wrong. Many students forgot the radius changes. All of you just consider turns increases, but you forgot the radius also will decrease n times. So that's why the field will become n into n times, which is n square times. That's the answer. Hello Kalyani, looks like you're in the wrong class. But yeah, 11th standard class tomorrow. By the way, let me tell you, today what is it? Last day of November, you know? Oh, let me also announce this before I go ahead. What is the plan ahead? See, you will have maths paper just when maths paper is over. Okay? Till the time you have physics exam, that's on 10th of December. What do you want me to do? What do you want me to do? Please let me know in the comment section. after the video ends, if you're even watching this video recorded, okay, in these few days, 7th, 8th, 9th, we are going to do lots and lots of things. I am planning nice revision sessions. Yes, lots of physics, but you have to promise that you have to come over here. Lots of physics sessions. Formula revision, we can have formula revision. We can also have some nice sure shot kind of questions, most high weightage questions, which can have a very good chance that these kind of questions will come in the examination. I can do that research for you. Yep, we can do that. Definitely most expected MCQs. Yep, and I will also probably do formula revisions and all of that. So lots of things planned over here. So revisions, MCQs, case studies, okay, formulas, everything planned for you. But just that you have to promise you're going to come. And one more thing, as soon as the exam is over, you will have discussion also. I'm going to discuss this paper. Okay, as soon as you come out of the hall, I know you'll be like, sir, physics is done, why to worry about it? Let me think about next exam. No, we'll discuss the paper also. So you can get all your friends along when this is going to happen. Now, for the next few days, no physics classes for 12th standard. You will have only classes for 11th standard. As soon as maths paper is over, you will have only physics classes for 12th standard. Is that clear? Give me a yo, thumbs up. I'm always there for you. For those who have thought, Shreyas sir is running away. No, Shreyas sir is always here. And you have seen that for the last years, your senior batch, I was there till the end, till they got counseled for their college admissions, till they got into a college. So I am also going to be there with you, be it 11th, be it 12th standard. Maybe not a Menti session, Pranav. Yes, assertion reason also, Ishwar, definitely. Yo, perfect. Ampere's loop law. Okay. Now, just like you had Gauss's law where you used to take a surface area and find out the field, here, what do you do? In Ampere's loop law, what does it say? If you have a bunch of wires, this is carrying current I1, this is carrying current I2, this is carrying current I3, let's say this is carrying current I4, okay, and you go along a path like this, maybe, okay, maybe you go along a path like this and come back over here. This is a path that you take, this is the path that you travel. At every point in this path, you are going to encounter some magnetic field. Let's say the magnetic field at any general point is given by B, and you travel a distance dl along that path. Then if you take the dot product of that, B dot dl, you go to the next point, B dot dl, next point, B dot dl. You keep on adding it up. What is the meaning of addition? Summation, that is integration. Then when you come back to the same point, because you are coming back to the same point, that's why cyclic integral. Understood? That term will give you mu naught into the currents which are inside. Into the currents which are inside. Which are the currents which are inside? I1, I2 and I4. Do you see I3 is outside? So all the currents which are inside, but not all currents should be added because there is a sign convention for that. How do you do it? Well, let's do this. First of all, curl your fingers in the path which you have traveled. You have traveled like this, so curl it. Where is your thumb going? This way. So I1 and I2 are positive. So I1 plus I2. So I1 and I2 are positive. I4 is going to be negative. So that is your Ampere's loop law. That's how you apply it. Perfecto? Yeah. So that B is the net magnetic field. True. Yes. Okay. Yes. Definitely, Mr. Zerg. We are going to have very good questions. Don't worry. Let's do some questions. But before that, standard formulas. Magnetic field due to a solenoid is mu naught Ni. But this N, what is this N? This is turns per unit length. That's one big thing which many people miss. This is the magnetic field inside a long solenoid. But when you are at the end, the field is weak, and that weak field is exactly half of that strong field which is there inside. Here it is strong, but when you go towards the end, the field is exactly half mu naught Ni by 2. Okay. The classes will be in the evening, Rishabh. Yep, towards the evening, around 7 o'clock, 6:30, like that. Okay, that's the time when I want you guys to be there. Okay, cool. Next thing, if you have a toroid, then, okay, I don't know why the formula has come multiple times, but it's okay. So then the field inside this toroid, when I say inside, I mean just here. The field inside this toroid is given by mu naught Ni, but this N is just the number of turns. What is this R? This R is the average radius of that toroid. Is the average radius of the toroid. Okay, fair enough. Let's start solving some questions. Ishwar, yes, I'll be taking class tomorrow, but that will be for the 11th standard. Okay, same 7:30. Cool. Yes. We Priya, like I assured you, I'll be doing case studies plus assertion reason plus MCQs. Maybe I did not write everything, but yes, I'm going to do all of that. Don't worry. What is the magnetic field in the empty space enclosed by the toroid, toroidal solenoid of radius r? Okay, this is very easy. Okay, what is the answer? What is the answer? The answer is 0. There is no field outside the toroid. So when you have a toroid like this, okay, so the field here is 0, the field here is 0, but here the field is not 0. So in that thickness it is there, but outside and inside it is 0. Keep this in mind. Next question. Here it is. A solenoid of certain length and certain diameter, it possesses 10 turns per centimeter. Current of 5 amperes is flowing through it. The magnetic field at the axis of the solenoid is how much? Come on, calculations are there. Try to calculate it and see how much is the answer that you are getting. It's not that difficult. You can get it. Try it out for sure. Okay, Ankit, enjoying. I know it's always fun when you know stuff and you see lots of problems and the mood is set. Everybody's competing against each other. Very good. Let that mood be set and let you all enjoy these classes. So we have a solenoid. Interesting. Turns per unit length is given. Current is also given. What do we need to do? We need to find the field, right? So B is mu naught Ni. Mu naught is 4 pi into 10 to the power minus 7. Small n is turns per unit length. 10 turns per centimeter. 1 centimeter is 10 to the power minus 2 meters. That's n. Into the current. Is the current given? 5. What is the use of this? No use. This just tells you that it is a long solenoid. Nothing else. It's a long solenoid. That's it. So just do the math and see what you get. 4 5s are, okay, that's it. Yeah, 4 5s are 20. And you have this pi. And this will become 10 to the power 3, 10 to the power minus 7 and 10 to the power 3, 10 to the power minus 4. So this will become 2 pi into 10 to the power minus 3. So do we have 2 pi into 10 to the power minus 3? Yes, we have it. Option D. Option D. Correct. Perfecto. Perfecto. Many of you got option D. I can see that. Perfecto. Yes, it is there. Moving on to the last question before we move to the next topic. Come on, guys. The next topic is very interesting. We have to have that Enthuse. Don't let that Josh die down. If your friends are disappeared or if the friends have not yet attended this session, message them, call them, get into the session because Shreyas sir is doing the final marathon one-shot session for the upcoming term. One examination of 12 boards. The toroid has a core, inner radius this much, outer radius this much, these many turns. The current is also given. What is the field in the core of the toroid? So basically, you have a toroid like this. This is 25. This is 26. So basically, the average radius, the radius of the solenoid will be 25 plus 26 by 2, which is 51 by 2 centimeters. So the final answer, the field will be mu naught n by 2 pi r into I. Mu naught is 4 pi into 10 to the power minus 7. number of turns, is it given? Yes, somewhere it is given. 3500 divided by 2 pi into radius. So what is the radius? 51 by 2, but that's centimeter, so into 10 to the power minus 2 into current. What is the current? Current is 11. Okay, fair enough. That's it. Now do the math, you'll get the answer. Just see what and all will get cancelled, like 2 pi and 4 pi. This will become 2 times. This 2 into 2 will become 4, I believe. This 2 and that 2 will become 4. And 35 will come here. And 51 will come down. Fair enough. And that 11 will also come over here. And into 10 to the power 2, 10 to the power 2, 10 to the power 4, 10 to the power minus 7, and 10 to the power 4, 10 to the power minus 3. Just do the math and see how much are you getting. Yep. Chalo, come on. Let's see how many of you can get this. 10 to the power minus 3. Yes. 10 to the power minus 3. I think, oh yeah, it's there here, but it will be much more than that. Just check this out. Because these numbers on the top are higher. Yep. Is it coming out to be A? Very good. Cholan, Gopal, Subramanyam. No, Ritesh, just calculate it again. 2 zeros from here. These 2 zeros will go on the top. Okay, 10 to the power plus 2, 10 to the power 2, 10 to the power 4, 10 to the power minus 7, and 10 to the power 4 is 10 to the power minus 3. So finally, what are you going to get? Check this out. Are you getting 3 into 10 to the power minus 2? Very good, very good. Okay, Divya, good night. Actually, you should say good evening. Good night is said when you are leaving. Good evening is said when you are coming, irrespective of what the time is. Okay. By the way, the entire notes are going to be available in the Telegram channel. Go ahead, join the link. It is there in the description box below. Moving on to the next one. Force on charges. When you take a charge and throw it inside somebody else's magnetic field, then there is a force on it. That force is given by QV cross B. Correct? Remember that QV cross B is the force due to the magnetic field. And if there is electric field also, there is electric field's force and magnetic field's force together. So that will be QE plus QV cross B. Otherwise, the force due to magnetic field is QV cross B or QVV sine theta. V is the speed, Q is the charge, B is the magnetic field. Now, when you take a current carrying wire and you see that current carrying wire is placed in magnetic field, at the end of the day, a wire carrying current is moving charges. So if a moving charge experiences force, a current carrying wire should also experience force. And that force is given by ILB sine theta or IL cross B. Remember all these formulas, we are going to use them. Now, when you take two wires and place it close to each other and the separation between them is D, then they will attract or repel each other depending on the directions. Now, how to remember whether they attract or repel? And why do they attract or repel? Reason is, every current carrying wire will produce a field around it. And what does a field do to a current? A field, when it interacts with the current, it creates a force. So that's why the field of one wire applies a force on the other wire. And that's why there is attraction or repulsion. How to remember it? See, when you have same positive charges, what do they do? Repel, right? But in magnetism, it's exactly opposite. When you have currents in the same direction, they will attract. And in charges, when you have opposite charges, they basically attract. But in case of currents, they will do exactly opposite, they will repel. Okay, and what is the force formula? Okay, so same direction, attraction, opposite direction, repulsion. Mu naught by 4 pi, okay, I1, I2, okay, but this 2 will be there and the 2 will anyways get cancelled out. Yep. So when they are in the same direction, they will attract, correct. So you can write it as mu naught by 2 pi I1, I2 also, it's one and the same thing. Fair enough? Alrighty. And remember, this force is always force per unit length. Very, very important. This is a force per unit length. Be careful. Be careful. Okay. So mu naught by 4 pi into 2 I1 I2 divided by R. R is the distance between them. Or you can also remember it as mu naught by 2 pi I1 I2 divided by R. Okay. Yes, I'm going to do a session on formulas as well. Don't worry about it. Yes, I'm going to do it. All right, Saloni, don't worry. Yep. So Revant, I have derived it in my regular Pathfinder classes. You can watch the derivation peacefully over there because this is a one shot. So I'm focusing more on the formula, remembering and application and solving more problems. But yes, I have derived it. You can check it out. All right. So we have an electron traveling in the x direction. It encounters a field in the y direction. The motion will be straight, circular, in which plane? Come on. This is easy. This is easy. Come on, my warriors. You should be able to do this. Think, which plane will it move or which line will it move along? Draw the diagram. Probably it will help you. The electron is moving in the x direction. This is the velocity. It encounters a field in the y direction. V cross B, because the force will be Q V cross B. So the force will be in the z direction. The force is always going to be perpendicular to velocity. That means you will see it will go in a circular path, something like this. And which plane is this? This is obviously x and z. So x z plane. It will be a circular path. So as soon as it turns here, you will see that as soon as the velocity goes here, you will see the force will be like this. It will always be perpendicular. Okay, I hope you remember the formula. So radius was mv by qb. This is a standard formula for the radius of the circular motion. Perfecto. Which plane is it? XZ plane. Moving on to the next question. Very good, very good. It's not C. It's not C. It's not YZ. It's XZ. Many people made a mistake here. Okay, this is very common and interesting question. Proton, deuteron, alpha particle. They have the same energy, kinetic, moving in circular paths in the same field. Rp, Rd, R alpha are the radius. Then, which is the correct relationship between them? Which of these are the correct relationship between them? VSK Chaitanya, you just think carefully, aram se, you will be able to get it. Velocity is here, magnetic field is here. When you do V cross B, it comes towards you. So force is perpendicular to velocity, and as it moves, it will always remain perpendicular. So it will go in this horizontal plane, which is XZ plane. Wow, the day Ankit you say that, I mean, trust me, for sure, it's a clear-cut sign that probably you are going to get very good marks in the near future. Very good, Ankit. Loved that comment. Okay, great. People are confused between A, C. One of you also said D. Okay, energy is same. Energy. What is the radius? Radius is mass into velocity by QB. Mass into velocity, well, what can I do? I'll multiply by V. Oh no, I will not do that. I'll just do this. Mass into velocity is momentum, and this is QB. And how is momentum related to kinetic energy? Kinetic energy is P square by 2m. So P square is 2mk. So P is root of 2mk. Use that. So you will get this as root of 2mk by QB. Basically, radius is proportional to root of mass and divided by the charge. If kinetic energy is same, field is same, 2 is a constant. Now, think what this ratio root m by q is, for let's say alpha particle, let's say for deuteron, and let's say for proton. For alpha particle, the mass is 4, charge is plus 2. For deuteron, the mass is 2, the charge is 1. For proton, the mass and the charge both are 1. Root 4 is 2, 2 by 2 is 1. This is nothing but root 2, and this is nothing but 1. So alpha and proton both have the same radius. Alpha and proton both have the same radius, and deuteron has root 2 times more. Yes, I think option A. You can see that. Yep. Did you now see it? Perfect. So 1 alpha, P is also 1, deuteron is root 2, this ratio. So the radius will be more. Very good, very good. Moving on to the next one. Let's see how many of you can get this. 2 wires separated by some distance, and the currents are also given. What do you think is the force between them? What do you think is the force between them? Come on, my warriors. Let's see how many of you can get this. Straight away, direct application of the formulas. You should be able to do this. Very, very easy question. Come on, think about it. Come on, think. What will be the force? Which formula will you use? Force is mu naught by 4 pi. Remember, I just gave you 2I1 I2 divided by R, correct? So mu naught by 4 pi is 10 to the power minus 7. 2 is 2. Currents are 10 and 5. So 10 into 5 divided by distance, which is also 2. 2 goes. So it will become 5 into 10 to the power minus 6. Oops, I think some mistake is there in the slide. Oops. Okay, so ignore the options. Yep. So, okay, but will they attract or repel? Since they are opposites, they will repel each other. Repel because they are opposite in direction. So they will definitely repel. Okay, for sure. So I think these options need to be corrected. I will edit it in the PDF. Don't worry. All right, moving to the next question. Ignore this. This is wrong. Okay, so let's move to moving coil galvanometer. Okay, fair enough. Option E, yes, option E. What will you do, my warriors, if tomorrow or whenever you write the exam, you get a wrong question or a wrong options? Are you going to attempt it or leave it? Also, another question which can come in the objective exam. How many bottles does Shreyas sir have? Okay. Yeah, so if you attempt it and if it is wrong, then you will get marks. But if you attempt it, then what if it is actually correct but you made a mistake? Then you will lose marks. Remember, attempting is a good strategy when all the questions are compulsory. But when you have it as an option, because you have to select few questions only out of the pool, you have certain options, then it's better to leave that question, because probably you have made a mistake. Maybe there are chances that it is actually wrong, then you might get bonus. But then why take a chance when you have an option, right? So that's what you should do. Okay, so when it's compulsory, always attempt it, but when it is not compulsory, preferably leave it. Yes. You won't have so much time to think about it. Yep. Acha. S. Pranav says, I have only 3 bottles. Definitely not 3, much more than that. I'll probably put it in my next Menti quiz. Okay. Now, a moving coil galvanometer is basically a device used to measure current. You pass current, it deflects, and the deflection happens because of the torque. So, imagine you have a coil which carries current, and that's why it has some magnetic dipole moment, which is NIA, and you place this coil between 2 magnets that you see over here. So there is a magnetic field. That's why there will be a torque. You can see M and B are making some angle, so there will be a torque to rotate it. And because of the torque, what will happen? The needle will deflect. Now more the current, more the magnetic moment, more the torque, and more the deflection. Now in order to prevent this from continuously getting deflected, you have a spring. I hope you can see that. What does that spring do? The moment there is a torque due to the magnetic field, it creates an opposing torque. It creates an opposing torque. So this is a torque by the spring till an equilibrium is achieved. Till equilibrium is achieved. Now once that equilibrium is achieved, both these torques cancel and the needle stays there. So when you increase the current, the magnetic field's torque also increases, so it deflects more, and you need bigger restoring torque by the spring. The spring basically provides restoring torque. When you remove the current in that coil, the torque due to the magnetic field goes away. only the torque due to the spring, the restoring torque remains, it will pull it back to 0. So when you pass current, the field deflects it until it balances the restoring torque. You pass more current, it deflects more, and finally when you remove the current, the field's torque goes away, the restoring torque will pull it back. That's what it is. Correct. So the current is directly proportional to the angle of deflection, and you can see there is a very important relationship which you should know. Very, very important. Theta is equal to NBA by K. How do you remember this? How do you remember this, and what is each term? N is turns, number of turns. B is field. A is area. K is your spring constant. Spring constant, but in this specific case, it is the torsional constant. Torsion because it is rotation. Okay, so it's rotational spring because it is not expanding and contracting this way, it's being twisted. So it is a twist constant. Okay. How do you remember NBA? NBA is, NBA is associated with which game? Which game is NBA associated with? Football, cricket, badminton, tennis, basketball. Yes, NBA. So remember the basketball. Yes, so it is like that basketball, and you have the captain K, or you can call it C also. Some books also use the symbol C. Okay, instead of K they use C for a torsional constant. So here it was K, but some books also use the word C. So the captain of the basketball team is below. So NBA by, so that ball is coming over here. This is a basketball. NBA by captain, that is your theta by current. That is your angle by current. That's it. And C for capto also. Yes, that's what it is. Okay, so that's an easy way to remember. Now voltage sensitivity will be theta by V, and voltage is IR. So you don't have to remember this formula separately. Why? Because angle by voltage, voltage is IR, theta by I just know. Theta by I is NBA by K, so that R will come here. So you don't specially have to remember it. Okay, so if you remember this and you remember voltage is current into resistance, it's very, very easy. Fair enough. How do you convert a galvanometer into voltmeter or galvanometer into ammeter? Very easy. Simple things. Solve it like problems of resistance. Whenever this conversion comes, solve as if resistors. Solve as if you are solving resistors problem. What do I mean? If you want to convert a galvanometer into an ammeter, so the galvanometer, think of it like a resistance. Bypass. Whenever there is ammeter, it's a bypass. Whenever there is an ammeter, you have to bypass it. Okay. Think of this like AMM. Think of this like Amma. Amma is like your mom. Your mom is there standing because you are late from the party. You told you will come at 6 o'clock. You came at night 10 o'clock. So what will you do? You will bypass. You will slowly go from the other door. So whenever your mom is standing with one flying chappal, you are going to bypass. So you are going to take another route, right? You have to remember that bypass. And you will bypass via the shunt. So what is shunt? Shunt is your friend. Is going to help you that bypass. So remember this circuit. This current is basically the range of the ammeter. That current will partially go through the galvanometer, partially go through the shunt. So there will be some current through the galvanometer, some current through the shunt. And remember, whenever you have parallel circuits, resistors in parallel, they are inversely proportional. So Ig by Is will be Rs by Rg. That's it. This is nothing new. You know this. What did I say? Solve as if resistors. Just keep this in mind. Oh, Priya says exactly what all. Oops, I'm not going to say it. Okay, I don't know that. Okay, yes. Fair enough. So this is the range. You do not allow all the current to pass. Some of the current will go, rest of the current will go from here, and this is the standard ratio. Yeah, that's one thing. When you use as a voltmeter, then there is no bypass. You pass through it. You have to pass through it. So you have your resistance of the galvanometer, you have the resistance of the series resistor. There is no bypass. Whatever current flows through the galvanometer will also flow through the series. And remember, the total voltage across this is the voltage that you will be measuring it for. I mean, whatever is the range. So that will be the range of that voltmeter. Because voltmeter is always connected in parallel. So your device will be here. So this is the points where you will be measuring the voltage across. This voltmeter has two resistors in series, and that is connected in parallel where you want to measure the voltage. Just keep this in mind. Now use your simple Ohm's law. V is I into R. So using Ohm's law, what do you get? The voltage is I into the total resistance, which is Rg plus R series. That's it. Now tell me, is it difficult to remember the way I have taught you? Is it now difficult the way I have taught you? It is not, right? Else you will just keep on remembering some weird formulas. Hello AN. Glad to know that, Harita. Very good. Yes. Yeah, so for ideal ammeter, we must let the maximum current pass through the shunt. Correct. Perfecto. Perfecto. Chalo. Let's move on to some questions solving. And here we have the first question on your screen. Current sensitivity of a moving coil galvanometer is this. Voltage sensitivity is this. The resistance of the galvanometer is how much? Resistance of the galvanometer is how much? Yes, Magnesh, it is possible. But with the current competition, it's difficult. Yes, you can try. But I would say don't take chances and better take help and have a mentor who will always help you, and you should be associated with the competition. You should get the feel of the competition. Give those test series. Okay, so let's solve this question. D, are you sure? Okay, so when I say current sensitivity, it means theta by I. When I say voltage sensitivity, it means theta by V. And we all know that V is equal to IR. So this is sensitivity of current. This is sensitivity of voltage. So that means the voltage, think from here. If this is equal to sensitivity of voltage, voltage will be theta by sensitivity of voltage. Current will be, take current on the top, it will be theta by sensitivity of current into R. Theta, theta goes. So I will get, okay, theta, theta goes. Take that SI over there. SI by SV will be R. So just substitute the values. What is the value of SI? The value of SI is 40 divisions per ampere. Voltage sensitivity is 2. So 40 by 2, that is going to give you 20 ohms. Very good. Very good. Very good. Looks like many of you got it. 20 ohms. Perfecto. Yeah. Let's move on. Let's move on to the next one. Okay, what's the next one? Let's see. Galvanometer has a coil of resistance this much. Full scale deflection 5. How will you convert it into an ammeter of range 0 to 5 amperes? How will you convert it? Let's think about this. Ammeter. Ammeters mean Amma. Amma is there. Okay. So let's see what will Amma do now. So we have a galvanometer. What is the resistance of the galvanometer? 40 ohms. This is your galvanometer. Okay. And then the range is 5 ampere. What did I say? You always have the range over here. This is 5 amperes. You have to bypass it through the shunt. So this is the shunt resistance. Now the question is, you want to convert it into an ammeter of this much range, and the full scale deflection current is 5 milliamperes. So only 5 milliamperes can flow over here. If 5 milliamperes can flow through the galvanometer, out of 5 amperes, hardly 5 milliamperes is going. So my question to all of you is, how much is going through the shunt? How much is going through the shunt? Think about it. How much is going through the shunt? Think, guys. 5 amperes, 5 milliamperes, hardly anything is getting lost. It will be approximately still 5 amperes. Approximately still 5 amperes. Very good. And what did I just tell you? ratio of currents inversely related to the ratio of resistance. So 5 milli means 10 to the power minus 3 divided by 5. This is through galvanometer. Galvanometer by shunt will be shunt by galvanometer. Shunt by galvanometer, which is faulty. So 5 goes. So RS will be 40 into 10 to the power minus 3. Is it there? Yes, it is there here. This is exactly this. 4 into 10 to the power minus 2. B option. B for bomb. Oops. Rishabh, don't do that. YouTube has sensors, artificial intelligence. They detect people and they might send FBI into your house. They read all your chats. Very, very careful. Be very careful. That day I was talking about something. I was talking about explosion and all. Then suddenly I got call from police. Are you planning some attack? So I was like, no sir, sorry. I was just talking about something else. So be very careful. Everybody is listening. Okay, chalo, let's go ahead quietly. Okay, say sorry Shaktiman, say sorry FBI, say sorry SCI, everyone. Yep. You don't know who is listening. Galvanometer coil of 50 ohm resistance shows full scale deflection for a current of 5 milliamperes. How much resistance will you add to convert this into a voltmeter? Very interesting. So we will solve question on voltmeter also. Okay, let's do this. Okay, so we have this galvanometer which has 50 ohms resistance. This is your galvanometer. Then current is 5 milliamperes. Okay, this is 5 milliamperes. Obviously there must be a series resistance. You want to convert it into a 15 volts range. Remember, the entire voltage across it is 15 volts. And what did I just give you? I gave you the voltage is the current into resistance of the galvanometer into resistance of the series. Voltage is 15. Current is 5 milli, which is 10 to the power minus 3. Correct? Okay. Now, galvanometer resistance 50. Resistance of the series I do not know. Interesting. 5. Okay, this 5 and this is 3. So when it comes over here, this will become 3000 is 50 plus RS. So RS is 2950. Is it there? Yep, it is there. A for Agra. Very good. A for Atlanta. A for Antarctica. A for Apple. Very good, very good. Let's move on. Yes, finally we have reached EMI. And what is coming after EMI? You have AC and transformers. So stay tuned. Don't go anywhere. Even if you are feeling hungry, ask your amma not to give flying chapel. Please give me food. Yes, please ask for food on the table because you don't have to go anywhere because Shreyas sir is here for you. Even I have skipped my dinner. Okay, I'm going to have it after the class. So ask for dinner on the table wherever you are. Okay, so what do we have? Magnetic flux. What is flux? Flux is flow. Magnetic flux is flow of magnetic fields, correct? And what will it depend on? How many field lines are piercing through an area? More the field, more the flux. Bigger the area, larger the flux. The angle will also decide the flux. Angle will also decide the flux. So, same like electric flux, it was E dot A, here it is B dot A. B A cos theta. What is theta? Angle between field and not area, area vector. Be careful, a lot of students think it's the angle between field and area. No, it's not the angle between area and field, area vector. Area vector is always normal to the area, okay, the surface. Very, very important. Unit is Weber. Very good. Okay, next, Faraday's law. So, what do you do in हमारा क्लास कब स्टार्ट होता है सर? तुम लोग का क्लास तब चालू होता है when I actually come over here. So usually at 7:30, but today at 6:30. He said that if flux, okay, which is passing through a coil or any conductor is changing, so when this flux changes, then you have EMF induced in the coil, and this EMF is directly proportional to the rate of change, or it is d phi by dt magnitude wise. D phi by dt is basically rate of change of the flux. Very, very important. Now the moment you have EMF, that will also create induced current. And what will be that current? It will be that EMF divided by resistance. So it will be d phi by dt into 1 by r. That's what the current will be. Now, Tesla, what's the unit? By the way, see, flux was B into A. If there was a mistake, I'll correct it over here. This is Weber, this is Tesla, and this is meter square. So 1 Weber is 1 Tesla meter square. It's not Tesla meter, it is Tesla meter square. All right, great. Great, cool. Now this is all Faraday's law. There is one more law, and that is called as Lenz's law. So this was Faraday's law. What is Lenz's law? Lenz's law gives you the direction. It says if the flux tries to increase, so what does Lenz say? It's like opposite. It is like basically Battamiz Bachcha. It is like this Pandu over here. Okay, who is he? He's very nalak, Battamiz, like does not listen, always a rebel. So Lenz is basically rebel. So this is his father. Okay, this is father. His father says increase. What will this induced current say? This is induced current, and this is your flux. So if the father says increase, the induced current will try to create a field which will oppose the increase. So it will always oppose it. And if this flux says decrease, then he will say increase. Exactly opposite. Yes. Great. So Divya, what do you want me to tell? Please tell me. I'm studying class 11th. क्योंकि मुझे next week में mid-term exams है. Divya, just watch my 11th standard classes, nurture series. Okay, so today's class is for 12th standard. Don't worry. So always opposes the change if it tries to increase. So say for example, in this case, if you move this magnet inside, you can clearly see the field lines in it. The flux is increasing. Flux inside the coil is increasing. You can see more and more lines will enter in. So by Lenz's law, you should decrease it, you should weaken it. So the opposing flux will be this way by Lenz's law. How do you create the opposing flux this way? Hold your thumb in the direction of the opposing flux. See how the fingers curl. The fingers will curl like this. So this is the direction of the induced current in order to produce that flux. Understood? That's the direction of the induced current. Done? Done? Got it? Everyone? Perfect. Chalo. So I have put it on print for your sake. So magnitude wise it is d phi by dt. This minus sign which you see is just for the direction. So when you incorporate Lenz's law, it becomes minus. Magnitude wise it is just derivative. Let's solve a question. Harita, you can get the access to the previous live sessions in this channel. Go to videos. There is video. Okay, just click on the video. You will be able to see, just like over here. Okay, just if you're watching this, where are you? Yep. We Enthuse videos. That's it. You will see. This is me. Yes, that's the same me. Okay. Yeah. I look different here. Okay. I had colored hair. Yeah, that is a different story. But yeah, that's me. Okay. Just watch that class. Cool. Let's see if we can solve this question. A small piece of metal wire is dragged across the gap between the pole pieces of a magnet in 0.5 seconds. The flux between the pole pieces is known to be this much. Estimate the EMF induced in the wire. Okay. Where do we start? Estimate the EMF induced. The moment you see EMF induced, think of Saturday, Faraday. Yes, you have to think of Faraday's law. So the moment you see Faraday's law, what is Faraday's law? EMF is d phi by dt. Okay. The flux is known to be this much. That means if you take that coil between the magnets, earlier there was no flux. You take it inside, the flux is this much. So the change in the flux is basically 8 into 10 to the power minus 4 Webers. In how much time? In 0.5 seconds. 0.5 is half. 2 into 8, 16. 16 into 10 to the power minus 4. Yep. So I think it is 1.6 into 10 to the power minus 3. Perfecto. Very good Cholan, Rishabh. Very good Harita. Very good Sashank. Janya studies has gone into Saregamapa. Very good, very good. Let's move on to the next one. A long solenoid with 15 turns per centimeter has a small loop of this much. Oops, this was supposed to be, I think, okay, so what is the induced EMF? Okay, I think this question, there was some mistake in the printing. I remember, I'm not sure what was the mistake, but I think these units and these values were not matching. So I'll just put it up in the PDF, but I'll put the answer as well, okay? So I'll just correct this and put it up, don't worry. Okay, I remember there was something, some mistake over there, okay? Some unit was missing or something. Let's ignore that. But anyways, I'll just tell you the theory behind it. Just forget about the answers. I'll just tell you how to solve this. Okay, I'll just tell you how to solve this. Forget the values. Okay, so we had a solenoid of 15 turns per centimeter. Small loop of area is placed inside the solenoid normal to the axis. The current changes from this to this in 0.1 second. What is the induced EMF? So here you have a solenoid, something like this, okay, and there is current flowing in the solenoid. What will this current do? It will create magnetic field, okay, it will create magnetic field, and you have placed a small coil inside, okay. So EMF induced in the loop of certain area, let's say the area of this is A. Then the question is, if the current changes from this to this in this many seconds, what's the EMF induced here? How much EMF is induced in this coil? Okay, I'll tell you what to do. If you change the current in the solenoid, what will change? Field will change. If you change the field, what will change? Flux will change. If you change flux, what will happen? Faraday's law, EMF will be induced. Correct. Let's see what happens then. So the EMF is change in flux divided by the time. Now the flux is nothing but field into area. Correct? Flux is field into area, but area is not changing, field is changing, so bring that area outside. When derivatives, always the constants come outside, so it will become area into delta B by delta T. Now the next thing that I will do is B is field due to the solenoid. What is the formula? Mu naught Ni. So this will become del by del T. Mu naught N is turns per unit length. So I think it's already given 15 turns per centimeter. So N is given into I. Mu naught is a constant, N is a constant, I is not a constant. So leave that inside, bring other things outside. So area into mu naught into N into delta I by delta T. So now you know everything. I think the units of this, I'm not sure if it was 2 centimeter square or meter square. So that needs to be done. So this you put it as 4 pi into 10 to the power minus 7. Put this as 15, but that is per centimeter. So into 10 to the power minus 2 will be there below. Change in the current from 2 to 4. It is 2 amperes change. In how much time? 0.1 seconds. So this is 0.1. So solve this and you will get the answer. Is it understood how to do? Okay. Understood, my warriors? Perfecto. Okay. So that's how you need to solve the question. Perfect. Let's go to the last few things. More half an hour or 40 minutes max and then we'll be done. Yep. Shreya, I'll be doing that. Don't worry. Self-inductance, mutual inductance. Formulas, quickly, let's do this. Self-inductance formula, phi is Li, one formula. Phi is the flux, L is self-inductance, I is the current. EMF, L di by dt with a negative sign. E is the self-inductive EMF, L into di by dt. Di by dt is the current. So when you pass current through a coil and the current changes, EMF is induced in the coil itself. That is self-induced EMF. That is given by L, inductance, into di by dt. What is the unit of L? Henry. Okay, SI unit is Henry. Self-inductance of a solenoid, you can remember it, mu naught into N into number of turns per unit length into area. So that's one formula which you can remember, but I don't see many problems on this in the CBSE board at least. Mutual, the change in the current in one causes the change in the current in the other. It's very similar. Flux is M into I. The flux in another coil is mutual inductance coefficient into the current in the other coil. So that's the formula. Same formula for EMF. Instead of L di by dt, it is M di by dt. That's all. Okay. Mutual inductance of a solenoid inside a solenoid, that's there for J, but as such for CBSE, I don't think you should worry about it so much. Let's ignore. Let's go to the first question coming up. About I in the L's formula, I is the current, Shreya. I is the current. Okay, great. In which lengths must be considered? So see, I'll tell you what happens in the self-inductance formula. This small n is actually turns per unit length. This is turns, this is length. This is what happens. And this n is just the turns. That's the formula. Whereas when two solenoids are placed one inside the other, the formula is still the same, just that here you will have n1, n2. Turns in 1, turns in 2. That's the only change. You can see that also. Okay, it's there over here. You'll have n1, n2 divided by L. So that's the change, but that's more towards the J side, not for CBSE. Okay, let's solve this question. Fair enough. There are two coils such that the current flowing through the first coil experiences change in current of 2 amperes to 10 amperes in 0.4 seconds. How much is the mutual inductance between the coils when the EMF induced is 60 millivolts? Okay, so that's what I gave, Archana. I just gave you the formula for self-inductance, okay, previously, and the mutual inductance formula had N1, N2. For L, it is just NN, that's all. Okay, come on my warriors, let's see how many of you can do this quickly. Okay, so EMF is L del I by del T, magnitude wise, I'm just talking about it. So 60 millivolts, so 60 into 10 to the power minus 3, mutual inductance, oops, sorry, not L, M. So M, and what is del I? 2 to 10, that's how much? That's 8 in how many seconds? 0.4. So that's it. Bring this here, 60 into 0.4, 6 into 4 into 10 to the power minus 3. Bring that 8 below, that is M. So this will become 2, 2 and 3. So 3, so M is basically 3 into 10 to the power minus 3, which is 3 millihenry. Option A. Correct. Perfecto. Perfecto. Excellent. Let's move on to the next one. Okay, let me also tell you, there is one very important announcement before I go ahead. For the next few days, right from this entire December, okay, for the entire term 1 exam on the Vedantu platform, okay, before every exam, so before maths exam, before your physics exam, before your chemistry exam, before your bio exam, every day on the Vedantu platform, you're going to have sessions for chapter wise. You are going to have special sessions for MCQs, case studies, and then also you're going to have assertion reason question, special sessions throughout the day, all day, and they will be conducted by all experienced faculties. And you can try out the pro subscription for hardly 1,530. This is for 15 days. This is for 15 days, and you get 15 days extra. And all you have to do is make sure that you avail the 10% off using this code SHHPRO. So I would say, even if you don't want to take full year subscription, you can take for 15 days, get that 15 days extra, and avail all these lectures plus problem solving, these assignments, everything every day before the examinations. It's not just one day, in fact it starts 2-3 days before. Okay, so that's one announcement that I wanted to make for you. That's a smart way of making use of the pro subscription for 15 days. Yeah. Yes, so Ishwar, like I said, ये sessions जो रहेंगे, these sessions will be every day before your each individual exam, right from morning till night, and all the pro users can avail full benefit because these are absolutely free of cost if you are a pro user. So if you take pro subscription for the next 15 days, not only will you get these classes, but after your examination is over, after 15 days also, you will get additional 15 days plus the 10% off, and you can even join my classes in those remaining 15 days, my micro courses. Cool. Sure. Let's move on to the next one. AC, that's the last chapter. AC is alternating current. The current changes the direction. This is the amplitude. This is the peak voltage. But you also have one more parameter called as the RMS voltage. What is RMS? RMS is basically the maximum divided by root 2. So remember, RMS is always max divided by root 2. You should know the value of root 2, which is 1.414, and also the value of 1 by root 2, which is 0.707. So remember these two values, very, very important for solving the questions. Okay, usually your voltages, currents will be of this form. You can see here, this is the max or the peak value. This is the instantaneous value at that instant. This omega, you can see, is the angular frequency, just like SHM. F is the frequency of the SHM or the oscillation or that AC. Omega is also called as the angular frequency. Okay, same thing for voltage. Instead of current, you put voltage. This is maximum voltage. Sine or cosine, that really doesn't matter. Okay, so I have put up all these things. Now remember one thing, whenever you talk about RMS value, it will be here. The average value, a lot of students get confused. When I say average, the average of one entire cycle, the average of a cycle is always 0, but the average of every half cycle is not 0. You can see the average value, this value, this value, this value, this value, this value, this value, average will be somewhere here, but for one entire cycle will be 0. Keep this in mind. Okay, very, very important. Okay, so this average that I am talking about, this average is over here. This is for half a cycle, not for the complete cycle. Okay, keep this in mind. So this is very, very important. This is not the complete cycle's average. Keep this in mind. What is that? N in 2 pi NF? Was there an N over there? I'm not sure. I'll just go back, but I hope this is clear. Okay, is there an N? Oops, why is that N there? Oops, this N was not supposed to be there. Okay, this N was not supposed to be there. Okay, so ignore that N. This is not supposed to be there. Some printing mistake, I guess. Okay, chalo. Moving on to the questions coming up on your screen. Will this live be uploaded to watch later? Yes, Niveta, it will be. But right now, watch the current portion live. Whatever you missed, watch it later on. Okay? At least this much part, don't keep it pending because that next will never come. Let's do this. The peak value of alternating EMF is given by E naught cos omega t, and the peak is 10 volts. The frequency is 50 hertz. At 1/600th of a second, the instantaneous value of the EMF is going to be how much? How much is the instantaneous value of the EMF going to be? Let's try to solve this question. The EMF is given by this value. It's clearly mentioned that 10 volts is the peak value. It's mentioned. Peak value is 10 volts. So that means E naught is 10. So E will be 10 cos omega. What is omega? Omega is 2 pi f. Remember that? So 2 pi f. Frequency is 50 hertz. So into 50. Into t. What is the value of t? It is 1/600. Let's see, what do we get? You'll get 10 cos 1010 gone. 2 into 5, 10. So 10 gone. So I think it is just cos of pi by 6. Cos 30 is root 3 by 2. So it will be 5 root 3 volts. So 5 root 3 volts is here. That's it. Done, done, done. Very good, Rishabh. Very good, Cholan. Very good, Ashika, Shreya. Very good, Shashank. Very good, Ishwar. Perfecto. Come on, my warriors. Don't lose that Josh. 3 questions in 1 question. My God. Very nice. Let's see how many of you can solve this within 1 minute. Let me put a timer. Let's see who are all those students who are going to get very nice marks in the upcoming exam. Hi, Kajal. Good evening. Good evening, bacha log. Join in. Join in. Let's see. Current is given. Find RMS, frequency and average. The total average current. Let's see how many of you can do this. If the current is this much, find the RMS and the frequency and find the average. Very easy. If you get even 1 or 2, you can start eliminating the options. Okay. Yes, just like the admin is saying, keep the Josh high. B. Sure. Harendra saying A. Time is going to be up. Come on, do it within the time limit. Oh, thank you so much, Niveda. It means a lot. Means a lot. Okay, let's solve this. So RMS. RMS is nothing but maximum. This is your max current. So it is basically 5 by root 2. So what did I just tell you? Root 2's value you should know. What is the value of 1 by root 2? Rather, it is 0.707. So if you multiply that, I think you are going to get 3.535. It's obviously going to be less than 5, but not 4.53 for sure. And frequency. Frequency is nothing but, you have to find it by 2 pi f is nothing but 300. This is 300. So f is, this will go like this. This will become 150. So this will become 150 by pi. So 150 by pi, pi is 3. So 150 by 3 is 50. But pi is actually 3.14. So it will be slightly less than 50. Slightly less than 50. So 47 point something. Average has to be 0. So it will be one of them. So you can see out of these two, B option. Done, done, done. Yes. So Naveen, this is the last video of its kind. I did one video yesterday. Before the physics exam, you're going to have mock test questions. You're going to have most high weightage questions, formula sessions, and many more such different full syllabus sessions just before the exam. Okay. Last few formulas. Let me explain this to you via phasor diagram. That will be better for a series LCR circuit. Remember, voltages across each component are not in sync with the current. So you use phasor diagram. If this is the phasor of the current in the circuit, remember the current is same for all of them, the voltages will be different. For example, resistance has the same phase, or the voltage of the resistance is the same phase as of the current. So that's why you will show the arrow marks together. They increase and decrease together. But for the inductor, it is ahead. So the voltage across the inductor is always ahead by 90 degrees, and for the capacitor, it is behind by 90 degrees. Each of these phasors are like vectors. Think of these three like vectors. So you will be able to immediately see these two vectors will partially cancel, and here you will have VL minus VC vector. The base will be VR vector. The resultant will be the total voltage of the circuit, which is just V. So that will be the total voltage. Okay, so that's the total voltage across the circuit. And this angle is called as the phase difference between total voltage and the current. So their voltage totally and the current are not in the same phase. Sometimes it could be, but most often they are not. That's how it is. Okay, next, what else? You have formulas like this. Voltage across the resistance is current into resistance. Voltage across the inductor is current into inductive reactance. Voltage across the capacitor is current into capacitive reactance. Resistance and reactance have same units. Their behavior is also same. They oppose the current. But For inductor and capacitor, they are not called as a resistance because they do not produce heat. XL formula is nothing but omega L, and for XC the formula is 1 by omega C. These are the things which you should know. Now the last thing that I would like to tell you is for the resistances. Just like you had these arrow marks, these phasors, these vectors for voltage, same thing you can draw even for resistance. So the resistance phasor always comes in the direction of the current. It always comes in the direction of current, and then you can draw the remaining phasors of inductance like XL and XC, and the vector addition of all these three. The vector addition of all these three is called as Z, which is nothing but impedance. What is it called? Impedance. So you can see Z is the resultant of all of them. So more often than not, you can see this formula Z square is R square plus, take care of these two phasors, XL and XC, both are opposite, so the resultant will be XL minus XC whole square. Use Pythagoras, R square plus this square is the hypotenuse square. That's the formula. And eventually you can also write the final formula as, this is voltage across resistor, inductor, capacitor. Total voltage is that, again the same current, the combined effect of all of them, what is it? Z. Total impedance. This is how you can remember all the formulas. Is that clear? Is that clear? Yes. So, chalo, let's go ahead to the next thing. Yes, all these things are there over here, and you should also remember this simple formula. Quality factor could be there. Okay, 1 by R root over L by C. Okay, that's the quality factor formula for LCR circuit. If they ask you a question, just directly use this formula. Cool. Let's solve some questions. Ready? Capacitor of 2 microfarad draws a current of 4 milliamperes. When connected across AC, the voltage drop across the capacitor is how many volts? Figure this out, my warriors. Come on, think about it. So we have a capacitor in an AC circuit, and the question is, what do you think is the final answer? The voltage drop across the capacitor is going to be. Come on, think. Well, so I just gave you voltage is current into capacitive reactance. Okay, now it draws a current of 4 milliamperes. So current is 4 into 10 to the power minus 3. Capacitive reactance, it's nothing but 1 by omega C. I just told you about it. So instead of omega, remember this was 1 by omega C, and omega is 2 pi f. Use the substitution. 2 is 2, pi is pi, frequency. Frequency is 300. Capacitance, how much is the capacitance? 2 micro. Micro is 10 to the power minus 6. Rest of the calculations you will be able to do, I'm pretty sure. I can just show you what and all you can do. 2, this 4 will get cancelled. Okay, I think you'll just be left with this 3 pi over here. 3 and pi. So 1 by 3 pi will be over here. And 2 zeros here. 10 to the power minus 6. It will become 10 to the power minus 4. It goes on the top. It will become 10 to the power 4. And 10 to the power minus 3. That will become 10. So 1 by 3 pi. Yeah. So 1 by 3 pi. You can see 1 by 3 pi. Pi is 3. 3 into 3 is 9. So approximately 1 volt. So I think it will be 1.06 volts for sure. Option A. Perfecto. That's how you have to simplify the question. Yep, it is 1.06. Next question coming up on your screen. No, Shivam, it is not D, it was A. Next question is also coming up on your screen. Quickly start solving the question. Here it is. We have an inductor and it's 1 Henry connected across 220 volts, 50 hertz supply. The peak value of the current is, figure this out. Peak value of the current is, okay. So we have to find out the current, voltage is given, frequency is given, inductance is given. VL is I, XL. XL is omega L. Omega is 2 pi f into L. Fair enough. So the current is asked, voltage is given, voltage is 220, current I don't know, into 2 pi into frequency which is 50 into inductance which is 1, Fair enough. So the current will be 1 0 I can cancel. Fair enough. So 22 and these few things will come here. 2 5s are 10 into pi. Great. But pi is nothing but 22 by 7. So this will become 10 and this is 22 by 7. This 22 goes. So this will become 7 by 10, which is 0.7. But this is not the answer. Be careful. The question says peak current. Whatever current you found, this was actually RMS, because this voltage is also RMS voltage. So the current you got was also RMS. So use your logic. So the peak by root 2 is RMS. So, it's valid even for current. So the maximum current by root 2 is RMS. So the maximum current will be RMS value, which is 0.7 into root 2. Root 2 is basically 1.4. 14 sevens are. It's going to come very close to 1. It's going to come, yes. So I think we were, yeah, it's going to come very close to 1. Everybody agrees? Yeah, it's going to come very close to 1. Very good. No, it's not A. It's not A. It will be C. Think about it. Yeah, makes sense, right? 0.707, which is almost 0.7 into 1.1. 14 sevens are 98. Yeah, 8. You got it. Makes sense. Yep. So it should be 1 ampere. Yes, it is 1 ampere. You can see that. It's 1 ampere. Cool. Let's see. Moving on to the next question. Yeah, 0.98, which is almost like 1. Okay. So instantaneous values of EMF and current are given. This is EMF, this is current. The impedance is asked. Very interesting question. Very interesting question. So this is VRMS. Oh, sorry, my bad. This is V0, maximum voltage. This is I0. And I just told you V0 is I0 into impedance. So V0 is 1.414. I0 is 0.707 into Z. Wait a minute. 1.414, that's root 2. 0.707, that's 1 by root 2 into Z. So Z will be root 2 into root 2, which is 2 ohms. So hence the answer is 2 ohms. Done, are done. Got it? Everyone? So that's how you have to solve problems, and that's why I told you these values are also very important. Perfecto. The answer is B. Moving on to the next question. Here we have it. Let's see. Consider the following LCR circuit and the voltage maximum which is dropped across the resistor. Across the resistor is 30, across the capacitor is 10, across the source is 50. Question is, what is the voltage across the inductor? Many students are going to make a mistake. Let me just write the values. Across the resistor, it's 30 volts. So 30 volts. Across the inductor, we have to find it. Across the capacitor, it is 10 volts. Across the source, it is 50 volts. So question is, how much across the inductor? Well, come on. Answer the question. Is it 50? Is it 30? Is it 40? Is it 10? I know what most of you are going to do. 50. This is 30. This is 10. How much is remaining? 30 plus 10, 40. 40 plus 10, 50. So answer is 10. No, that's wrong. You cannot add it scalar wise. It is vector. Be careful. No, it is not. It is not 10. That's why I told you. Be careful. It's vector. So voltage across the resistor is 30 volts. Voltage across the inductor, I don't know. Voltage across the capacitor is 10. And the total voltage is basically 50. If this is 50, clearly it should be understood. This is a right angle triangle. If this is 30, this is 50. How much will this be? Quickly answer in the chat box. How much will this be? This is a right angle triangle. Everybody knows 3, 4, 5. Pythagorean triplet, 30, 40, 50. So this will be 40 volts. And what is 40 volts? It is this minus this. So what should this be so that this minus this gives you 40? This minus this gives you 40. So what should this be? Think about it. This should be 50 volts. So 50 minus 10, because 40 will be 50 minus 10. That's the height of this. Got it? Perfect. That's how you are supposed to solve it. Don't make that silly mistake and write it as 10. Answer is, oops. Why is this answer given as C? This is wrong, 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 wrong. Okay, looks like A lot of corrections are needed. This is A option, option A. Okay, cool. Moving on. LC oscillations. Let's do some questions on LC oscillations. Main important formula is this one. Frequency is 1 by 2 pi root LC, or omega is 1 by root over LC. Whenever you have LC circuits, the charges go back and forth, and the time period of oscillation is 1 by root over LC. That's going to give you the angular frequency. Also, this frequency is also called as the resonant frequency, because whenever you have a LCR circuit connected to a source and the frequency of the source, if it matches the frequency of the LCR, what is the frequency of the LCR? I just gave you 1 by 2 pi root LC. If these two are equal, then the current in the circuit is maximum, and this phenomena is called as resonance. Okay, if this source frequency matches the LCR frequency, then the maximum current, maximum power, and when resonance occur, the power factor is 1 because the phase difference is 0. So cos of phi is 1. So power factor is also 1. Max power is delivered. Maximum energy is delivered. All these things are very, very important. Cool. Let's do the questions on this. We have a capacitor connected to an inductor. What is the angular frequency of free oscillation? Direct question. Mangalam, more 15 minutes, 10 minutes, that's it. Okay, done. After this, only transformer, 1 or 2 questions. Done. Okay, what do you think is the answer? Just apply the direct formula. Let's see how many of you can do this really quick. So, angular frequency, omega is 1 by root LC. So 1 by root over inductor. Inductor is 27 milli, which is 10 to the power minus 3. Capacitor 30 micro, which is 10 to the power minus 6. 27 into 3 is 81. So root 81. 10 to the power minus 3, 10 to the power minus 6, 10 to the power minus 9, and one of the zeros, so 10 to the power minus 8. Okay, so this will become 1 by root 81 is 9. Root of 10 to the power minus 8 is 10 to the power minus 4. 1 by 9 is 0.11 recurring into 10 to the power minus 4. Will go on the top, it will become 10 to the power plus 4. So this will become 1.1 into 10 to the power 3. Do we have it? Yes, I think we have it. That's the answer. Perfect. Done. Moving on. Power formulas. Everybody remember, the power in a AC circuit is Vrms, Irms, cos phi. Cos phi is called as the power factor. This is RMS, not the peak. Don't make that silly mistake. Vrms, Irms, cos phi. Phi is the phase between voltage and current. You can also write this entire thing, if you don't like it, as V, voltage across the resistor. Okay, the RMS value square divided by R. This also works. You can also write it as current in the circuit, but the RMS value square into R. Only the resistor loses heat. Inductance and capacitance does not lose any energy. Keep that in mind. Okay, keep that in mind. All right, moving on. Okay, so these are some special interesting things, like when it is resonating or it is not having inductance or capacitance, power factor will be 1, so it will be Vi. When it is pure inductance or pure capacitance, like I told you, only resistance loses energy, so the power consumed will be 0. Yep, okay, so keep this in mind. Last question in this part. There is an inductor, there is a capacitor and a resistor in series. Voltage is 10 volts. The power loss in the circuit at resonance is very simple, very easy, direct question. Voltage is given, inductance is given, capacitance is given, all are in series. How much is the energy at resonance? Keep this in mind. The word resonance means the power factor is basically 1. So all you need to do is that power loss will be voltage across the resistor, or So whatever voltage is there, yes, the voltage across the resistor square by the resistance. Now the voltage across the resistance will be 10 volts. So it will be 10 square divided by the resistance, which is 50. 10 square is 100 divided by 50, which is 2. Hence the answer is B. Hence it is B. Yep. Okay, so if the work done in DC and capacitance and resistance is 1 by 0, so infinite resistance, how charge will, not sure what your question is, Shashank. Maybe you can put it after the lecture ends. I'll definitely respond to it. Just put it up in the comments, okay? I'll have a look at it properly. Okay, so that's answer B. Next, okay, so again, a coil of inductive reactance has resistance of 8. Okay, I think let's do one thing, because I think the power factor part is not there. Let's just skip these questions. I don't want you to waste time over here. Just ignore these questions, okay, because I don't want to waste time in these things. Let's directly go to the ones which are actually there. Transformers. Let's move to this one. A transformer, what does it do? Number one, it works on the principle of mutual inductance. There are certain number of turns on one side, which is called as the primary side, certain number of turns on the secondary side. The ratio of the turns decides how much is the voltage going to be affected by. Okay, so remember this, the ratio of the turns in the primary and secondary is the ratio of the voltages in the primary and the secondary, but it is inverse to the currents ratio, I2 by I1. This is something which you should know. And very important thing, input power is output power. That means no loss which happens in the transformer. Whatever current you give on the input side, the power which is consumed, the same power comes on the output side. The losses are negligible, which is a very fair assumption in today's transformers. Okay, let's move to the question parts of it. An ideal transformer has 100 turns in the primary, 250 turns in the secondary. The peak value of the AC is 28 volts RMS. The secondary voltage is close to how much? Think about it. Yes, Rishabh, the masses are different, but proton and alpha particle have different charge. So the radius will be different because of the charge, not because of the mass. Momentum is same, the numerator will be same. Is that okay? Okay. Where did we reach? Amina, we have reached almost towards the end of the session. Okay. Darshana, I think eddy current, you can read it on your own, but it's very simple. I mean, there is nothing great about it. Okay. So just read it on your own. There are no questions as such on that. It will be just a theory pointer. If you want, I'll revise it just before the board examination when I'm going to do your revision. Okay. So during that, probably I'll do one question on that. Thank you for reminding me. Okay, so ideal transformer has 100 turns in the primary and 250 turns in the secondary. The peak value of the AC is 28 volts in the primary. The secondary voltage is how much? So Vs will be 28 into 250 divided by 100. Come on, do this. But be careful. Whatever voltage you get, this voltage will also be the peak voltage. The question is, what is RMS? So Vs, but the RMS value will be whatever you get here. So 28 into one of the zeros goes. This will be divided by 5. This will be also divided by 5. This will become 14. So here you will get 14 into 5, which is 70. So this is 70. So 70 divided by root 2. But wait a minute, 70 divided by root 2. 1 by root 2 is 0.707. 0.707. So 7 sevens are 49, and that is point. So I think it will be 50 volts. Just check this out. Around 49 and 50. It's almost very close to each other. Very close to each other. So that's why that value helps. 7 sevens are 49. That's what I have used. Yep. Is that clear? What I have done? Okay. Very good. Option A is correct. Moving on to the next one. The ratio of the number of coils in the secondary to primary of a step-up transformer is this much, 4:1. Current of 4 amperes is applied to the primary. How much current is there in the secondary? Very interesting. So number of turns in the secondary upon primary, current wise will be IP by IS. It's always opposite, I have told you. This ratio is 4:1. Current in the primary is 4. Current in the secondary is asked. So the current in the secondary is exactly 1 ampere. How many of you got it? Option C. Very good, Cholan, Harita, Ishwar. Perfecto. You guys are very quick. That's the answer. Option C. So that's it for today. And let me tell you again and again, if you want your doubts to be resolved and you want the marathon sessions chapter wise plus MCQs plus assertion reason, there is a very simple thing you can do. The classes will be conducted in English, plus I'll tell you what you should do. See, very simple thing. Right now if you're watching my class right now over here, okay, that's me. Go down and check this out. Class 12 JEE or CBSE Term 1 and 2. Just click on this. Now this is a pro course, this is a subscription. But the advantage now that you will get is for the next 15 days, every day almost you are going to have lectures for that particular board exam. So it's a maths exam. Before that you will have maths chapters being covered, assertion reason questions, homework, assignments, tests, everything. Mock tests are also there. You will get all of that for every board examination, every paper. And the best part is not just that, after the exam is over, you can avail other benefits of the pro course like my courses, modular courses, the crash course for JEE, the term 2 revision, the term 2 syllabus, everything will start. You can avail all of that without having to pay anything extra for almost like 1,530 rupees. So that's a very affordable price. I think you should definitely try it out for the 15 days. Plus you get extra 15 days when you use my coupon code. So try it out. Okay, that will be helpful if you feel that apart from YouTube, you need somebody to push you. That's one thing I would definitely suggest. There are 3 versions of Light, Classic and Plus. The Classic will have doubts. Plus will have, apart from doubts, it will also have personal mentor. But I would suggest for the next 15 days, don't even go for Classic, don't even go for Plus. It's okay. Just try it for 15 days, the light version. Make full use of the revision sessions. That's what I'm telling you. Okay, cool. So that's it from my side. I hope you have enjoyed the class. I'll be waiting to see all of you in my sessions, which I'm going to conduct on YouTube, plus the sessions that you are going to attend on the pro courses. Yeah, you can join the NEET classes also. Yes, I'm going to share that on Telegram too. Okay, Ankit, I am also enjoying the session, but I need to take a leave. I will definitely meet you guys again very soon. Okay, have a great time and please stay fit. Don't lose hope. Shreyas sir is with you. Do not forget to come just before the physics exam. All the 3-4 days before the physics exam, I'm going to be here. You have made a promise. You have to get your friends too. All right. Let's study together and let's crack this board exams also together. All the best, my warriors. See you on the other side. Have fun. Keep learning. Keep studying and work really hard. Shreyas sir is with you. Hasta la vista. Take care.